What's up? What's up? What's up? All right, so yeah, we got Ashish here. What's up, Ashish?
Hey, how you doing all?
Good, good. So we met at the Cosmic Summit. It was pretty interesting how we met too, right? Because
Mhm.
they was talking about the bus ride to Pilot Mountain,
Mhm.
and I already said that I was going to drive up there even before I even left my house to go to North Carolina. But then you said, "Oh man, I'm gonna miss out on that." And
Mhm.
me and Mike, Dave we were the only three in the truck. We had one
Mhm.
more seat, so yeah, I offered that seat to you, and we had
Yeah.
actually a great discussion on our way up there. But that's
Yeah.
actually how we met because we talked for what was it, about a 45-minute drive up there
Mhm.
and a 45-minute drive back, and then of course we hung up there, and the whole time at Cosmic Summit, so we got to know each other pretty
Yeah.
well over there. And you had this theory that you was talking about a lot
Mhm.
that we're going to go over today.
Yeah. Yeah. Thanks. I mean, I'd kind of not even really known about the Cosmic Summit until just like a week before. Originally, the way it all happened was I was going to go on a tour to Thailand with Praveen Mohan. And I talked to Praveen Mohan about why I wanted to go on the tour and stuff like that. And I told him a little bit about what I was working on related to reverse engineering megalithic structures. And he told me he was going to this thing called the Cosmic Summit, and he recommended that maybe I should go there and talk about what I'm working on. And so, literally a week before, I'm having this convo with him, and I didn't even know anything about a large community around this stuff. I've been doing this for years by myself, just as a hobby. And I like to travel anyway, and I'm really into rocks and ancient archaeology and stuff like that. And so it was just a hobby for me, but I had no idea that there was a huge community around this topic. And so once Praveen Mohan told me about this, I just literally booked my tickets and booked my flight there. I'm from Phoenix, Arizona. And so I booked my flight there right away. And yeah, then I met you. And because I had kind of joined so late, all the seats to the bus to Pilot Mountain were filled. And so I was kind of stuck and bummed that I couldn't go. But then, synchronicity happened, and you kind of showed up. You saw a little bit about what I was talking about, and then yeah, the rest was history. I really appreciate that ride. I mean, I would have not gone if it weren't for you. And so yeah, we had a good convo on the car ride up there. It's the first time I've really been talking about this to anyone because I've been pretty isolated out here in Phoenix. There's not a lot of people that work on this kind of stuff out here. And that's kind of a shame. Plenty of people are interested in hearing about this topic. I think everyone in the world is really interested in hearing about megalithic structures and all the cool stuff that's in ancient archaeology. But haven't had anyone to kind of like vet hardcore engineering ideas against. And so going to the Cosmic Summit gave me an opportunity to finally, for the first time in my life, actually talk to people that have done a lot of work on this, have looked into this stuff a lot, and kind of see if anything I'm saying actually makes sense.
So let me get this straight. That's it. That's interesting because like I was the first person. We were the first three people in that truck to hear that theory because you spoke the whole way up there, bro.
Yeah,
Like
I was talking the whole time.
and you was going deep in it, and uh it was actually interesting because I have it recorded. You remember I recorded it.
Yeah,
I
yeah,
have a copy of the recording
yeah.
of us in the
That's the
vehicle.
original. You have the
Yeah, that's the
absolute original first time I've ever fully laid out anything that I've been working on to anyone, really. Yeah.
yeah. That's why. That's
Otherwise,
why
up
is it,
until then, it's been in my head the whole time for years, many
it,
years.
and that's what made me and Mike and Dave from Mike and Dave's multiverse interested in hearing what you had to say because I mean you obviously we've had a discussion with you where you already went 2 hours. You already had another discussion with them just the other day. So
Hmm.
like I said, there's a lot that you can share on it.
Yeah.
And you have great
And I'm
knowledge
not
on it.
even
And you
done.
say yeah, and you're an engineer on top of that, right? Like that's your
Yeah.
profession, right?
Yeah. So I actually have a convoluted background. I'm not any one thing. I'm a multitude of things. The majority of my career was actually spent in finance. And so I was originally working for a hedge fund. and I was doing that in Hong Kong. It was a boutique hedge fund, and at that time, that was around June 2010. I was there, and I was a newbie out of college, and in June of 2010, Tesla IPO'd onto the stock market for the first time. And it was a newbie company at the time, and I was the newbie. And at that time, if you go back, you'll see there's just so much criticism for Tesla and all that, and nobody thought anything like that would work. And so they put the newbie onto the newbie company, and I ended up following that company, part of work and then part of just my personal interest. Later on, I came back to America, and most of my financial career was spent as a trader for Edward Jones Investments. And over there, I covered a variety of things, but a lot of tech is what I covered. And I did a variety of trading roles. So I kind of got deep into understanding the tech companies. And so this developed a pretty strong interest in tech. And along the way, I'm following Tesla the whole time. And that kind of led me down a pretty intense and deep path about learning AI long before AI was cool, 10, 15 years ago. Started learning about it. And in 2020, I decided to leave finance and I transitioned to AI. And so I went to school again, and I did a lot of research on computer vision. And my interest was on applications of computer vision to automated vehicles. And what I was trying to do was I was trying to model artificial intelligence off the human brain. And one of the things that, so my dad is a neurologist and a psychiatrist. My mom's a pharmacist with a bunch of degrees. So kind of like growing up, I've always had an interest in science and medicine, and my parents really wanted me to be a doctor. And I've taken so many classes and pre-med related stuff. Um, and so what I was trying to do was I was trying to understand kind of the best way to model artificial intelligence. And in my opinion, whether you're looking at real intelligence or artificial intelligence, you got to look at them the same. They're the same mathematical principles. And what I was seeing in the human brain was that there was a lot of mathematical principles applied. And I'm hoping someday I'll do a more public presentation about the work that I did in AI, but suffice for now to say that, in my opinion, the way to build AI models is to start on high resolution data. And so nowadays, and this will lead a little bit into how I got interested in the pyramids and megaliths. Um, Nowadays, a few years ago, ChatGPT and other large language models hit the scene really, really big. And just to kind of give a little flavor of what distinguishes my thinking versus conventional thinking right now in AI, like the large language models are obviously fundamentally built on language. And language in the human brain, it's a very like small part of the human brain on the left side. And it's just like kind of like this big, roughly. And language is just not, I mean, it's a significant part. I'm not trying to say it doesn't have value, but relative to what your brain focuses on overall, it's a relatively small part of the brain. And one skill set that I think is not common to this topic about megalithic structures around the world is language. And if you work in AI and you're familiar with large language models and you understand the principles behind it, you also actually understand the mathematical principles behind language. This is Noam Chomsky's work, very famous person. And this is like grammar in programming languages. The mathematical concepts behind it are similar to the mathematical concepts behind spoken word, spoken language. And this is all to say that language is fundamentally at its core a mathematical principle. It's pattern recognition. And so I don't know a lot of languages, but one thing that is useful, and if you do decrypting, if you're into cryptography or anything like that, you'll understand various mathematical concepts related to language. And this is common, this is like well understood. So since language is a purely mathematical principle, that kind of tipped me off on how to think about the human brain, because that's in the human brain. And so what I was working on was maybe it makes more sense because language is a very low resolution data stream. Text is very low resolution by comparison. So what I was working on was computer vision. And my thought was that eyes, vision, is a much higher resolution foundational basis to build artificial intelligence models on. And so if you start looking at the data pathways that go through vision in a human, you'll start to see these mathematical concepts also applying. So maybe something that is known but maybe not commonly known is that eyes are brain cells. I don't know if everyone knows that, but eyes are brain cells. And one of the first, not the first, but one of the first structures that was ever evolved in creatures, whatever you want to call them, one of the first structures was a photoreceptor, and a photoreceptor was attached to a flagella. And a photoreceptor is just a simple light exists or doesn't exist, 0 or 1, 1 or 0. And so initially, this way you can understand how binary math can begin. Light exists, doesn't exist. And since I know you're a mythology guy, you know in mythology what they say, in the beginning there was light. And so light, I think, plays a really big role in understanding intelligence. So in the eye, vision goes through a process to the back of the brain known as the visual cortex. And the visual cortex has multiple layers. And I'm a mathematical person, and order of operations matters. And here's another thing that I don't think is commonly understood. I don't think that a lot of people who study computer vision realize that they already automatically understand the visual cortex, whether they know that or not. It's not a common skill set to overlap computer vision with neuroscience. And I think that more people should be looking at that. I hope part of what I get to do is promote the idea that computer vision and neuroscience need to start being linked together, because the step by step sequential process that data information flows through the visual cortex is actually understood in computer vision. And I don't know if people understand that computer vision is explaining the visual cortex. And so, what I mean by that, if you look at the human eye, the ratio of cones, color cones in the human eye, there's a ratio of 26, 3, and 1 or 2 at the end. That means 20 gray cylinders, 6 red cylinders, 3 yellow green cylinders, and then 1 or
Hmm.
2 blue cylinders. And so these cones are how we interpret color, and they interpret different wavelengths of light. So what happens in V1, the very first step in the visual cortex, way in the back, is you process grayscale information. And in computer vision, we understand why you want to process video format data first in grayscale, especially in automated vehicles. You would understand, if you work on computer vision and related to automated vehicles, you would understand why grayscale is useful. It's very data efficient, but it's also the best way to detect motion. And so that's why we have a huge number of gray cones first. And if you look at what comes next in the ratio of your eyes, next is 6 on the red, the most common color cone. Um, and red is useful for threat detection, especially if you're underwater. Blue is not that relevant, but red would be way more relevant. And so red became connected. If you look at the visual cortex, that's the section where red starts to get connected to the amygdala. And the amygdala is your fear response, your threat detection kind of center of the brain. And so we can go through this process, and hopefully one day I'll do a more thorough presentation on this, but not to get too detailed, but it kind of gives you an idea of how you can start thinking about the human brain and AI being linked, especially as it pertains to computer vision. And I have more that I'll build on this, but this was the initial thought. And I think that another way of looking at the AI skill set as it may pertain to megalithic structures is if you look at the hieroglyphs. I think if you understand the mathematical principles behind language, like you would if you understand LLMs, you also have an advantage at understanding hieroglyphs. And a little bit of what I'm going to talk about is if you have an engineering background, even a general engineering background, but especially if you have specialized engineering backgrounds in topics that are relevant to megaliths, um, you'll start to notice that there's a lot of inconsistencies that don't make sense. And one of the glaring things that doesn't make sense about megalithic structures, one of the major things that doesn't make sense about the whole story all around the world in megalithic structures is a translation that is happening about the stories from the past. And I think the hieroglyphs is like a prime candidate for people in AI to look at, hey, this is something that doesn't look right. These translations seem to be inaccurate and not really how anything works. So if you go back and you look at the hieroglyphs and how they were originally translated, this is called the Rosetta Stone, everyone's heard. The Rosetta Stone is a broken off tablet, and it has one paragraph in Greek, and it has one paragraph in hieroglyphs. And what they did was they found a pharaoh's name in Greek and then the same pharaoh's name in the hieroglyphs. And then they tried to translate phonetically from there. And then that's pretty much how all of the translation began. And on top of that, you'll look at their grammar structure that they're putting inside these cartouches and stuff. And every time you hear an explanation about the language portion and the translation portion, it doesn't line up with how translation works or language works or any understanding of grammar the way that Noam Chomsky describes. It doesn't really line up with any of the mathematical principles that are well understood in AI. And so, one thing to understand about this, it may be possible to translate languages to some degree, some percentage, small percentage phonetically. So, an example of how this might happen a little bit is, for example, in Hindi, the word for shirt is kameez. And then in Spanish, the word for shirt is camisa. So these two words have a phonetic relationship. But that's not to say that if you know Hindi that you're going to just automatically know Spanish or be able to figure out the pattern recognition in Spanish or vice versa. That's not how anything works. The only reason that these two have a phonetic relationship is because the origin of these two words is in Arabic for both. And so that's the limit of what you'll be able to translate on a language phonetically, but the rest is not going to work that way. So unless Greek and hieroglyphs have a similar origin, the translation that they're doing is not going to work. And also on top of that, the grammar structure that they're talking about doesn't make any sense relative to what is conventionally understood about language. So in my opinion, hieroglyphs are a highly pictographic language. And this is why I think engineers should be involved a little bit more in, especially specialized engineers should be involved in megalithic structures. In my opinion, a lot of the hieroglyphs, the old hieroglyphs, the ones that are really high craftsmanship, carved into stone that look like they're laser etched, those hieroglyphs, because there are layers of hieroglyphs that are lower quality that clearly came later. The original hieroglyphs, in my opinion, there needs to be an electrical engineering lens that is applied to those pictographs. And then you look at those pictographs that way. And you will, in my opinion, do better at translating what's going on there than you would by listening to the conventional narrative. And there are just so many issues that are going on in Egypt, and I just at a certain point it just becomes ridiculous how many problems there are with conventional narrative in Egypt. And so actually what was it, a couple days ago, Trevor, I was going to say his last name wrong, Gassi, I think is what it is. Did I get that right?
Yeah,
Him,
there,
he did
there you go.
he did a presentation on Matt Beal's Limitless show, and he's talking about how many tunnels they're finding underneath the Giza plateau and all around it. And that's supportive of the SAR scans from the Khafre project. And I'll talk a little bit about that stuff. And also, there's an AI skill set that's relevant to helping understand some of that. So when I talk about that, you'll see some relationship there. But the gist of it is, we keep finding over and over again not just at the Giza Plateau, but many other megalithic structures around the world, including the ones in Mexico, including the ones in Cambodia, like Angkor Wat and so on, and including the Taj Mahal, that there are layers upon layers of underground construction as well, and extensive construction, not just a little bit. And again, it's so hard to believe the narratives that these thousands of megalithic structures, that literally thousands of them, megalithic structures all around the world, are just tombs and temples over and over again. So this part is what I think is a good intro for engineers that understand um, a lot of principles in the universe, and just basic understandings will get you really far. And it's also pretty apparent and obvious. I think a lot of people, after going to the Cosmic Summit, I think a lot of people understand now that these megalithic structures are not just tombs and temples. And so that's what I'm hoping to kind of convey. I'm looking at these megalithic structures all around the world collectively. And part of what I'm trying to show is that there is a set of patterns, commonalities between all these megalithic structures around the world. And what I'm hoping to do, I think now is the time where we have enough information, enough data, enough people looking at these things, where we can start reverse engineering these megalithic structures all around the world and try and figure out what these things are really about. Because these structures are too advanced and there's too many of them. There's advanced stonework that's well understood, advanced engineering and civil engineering applied to megalithic structures around the world, and there's so many of them, but they're also demonstrating application of principles across numerous subjects, all in one, each of these structures. So just to put some numbers behind it, there's more than 130 known pyramids in Egypt. There are a couple hundred or more known in Sudan. So between those two countries alone, 300 to 400 pyramids. And then in Mexico, there are hundreds of known pyramids, probably over 1,000 known pyramids in Mexico, or if you include the pyramids that are unknown in Mexico. Central America, same thing. South America, same thing. Asia is riddled with giant pyramids. I just went to Southeast Asia. Just went to Thailand, and I'll talk a little bit about that. There's pyramids there. Indonesia pyramids. There are pyramids everywhere. There's literally thousands of just pyramid structures alone, nothing else, just pyramids, and all of them megalithic. And then on top of that, there are megalithic structures that are not pyramids all over the world, tons of them. And the dating on these things is inconsistent. They range, the spans of datings for these megalithic structures are thousands and thousands of years apart, depending on where you want to look at. They're all totally inconsistent. But one thing that is consistent is that every major civilization on every major continent somehow achieved this high level of precision engineering work on all these structures all over the world. So every civilization was able to do it. Like, and not only that, they're demonstrating these principles like they're candy. Like they're doing it like regularly, like it's a joke for them. Some of these things look like they were doing really advanced things just for fun. Like if you look at Chichen Itza, I'll talk a little bit about that. So now is the time to start looking at all these megalithic structures around the world and see if there's a way to reverse engineer their true functional purpose, because it's not a tomb, and it's not all of them are not temples, just temples. Maybe some, but not all, especially not most. And there is another aspect of this. So one of the other unusual things is that for how impressive and how frequent megalithic structures are around the world, it is very difficult, and often heavy resistance is there to go and diagram the interior of these megalithic structures, or view any of these structures, any of the underground constructions underneath these structures. And so there's huge amount of resistance to be able to ever go and explore in detail any of these megalithic structures around the world. It's not just at Egypt. This is a problem everywhere. And it is extreme. And so one of the questions you got to ask is, why is the government involved in archaeology everywhere in the world. And the entire purpose of government's involvement is to roadblock every single time, over and over and over again. So this is starting to look a little unusual. And now, just to go back to the World War II era, we also know that Hitler was incredibly interested in archaeology around the world. And I'm Indian, and it's kind of sad to see, but the swastika was originally a Hindu or Indian symbol that was supposed to mean well-being, and unfortunately, it was taken by Hitler, and now its meaning and purpose is totally something different. And so that's really sad. But the link I'm trying to draw here is he was interested in Indian mythology, Indian archaeology, just like all the governments of the world are today. And so, since this is starting to look really suspicious, you should also look at that as being an indicator that, hey, something significant is going on here. And I think that there's something wrong with our timeline. And I hope to demonstrate a little bit of that.
Yeah, when you talked about so many great things. So one of the things that stuck out to me is how you talked about language. Language is understood by what people see. You know what I mean? And they're not necessarily going back to the origins. That's why I like etymology so much, because it gives you the origins of the word, right? And I can understand every point that you're trying to make as long as I understand which version you're using, because sometimes definitions and meanings can contradict each other. Um,
Yeah, that's
so
the other. Oh, sorry.
go ahead.
That's the other problem with phonetic translation. Something that is understood by probably everyone, but just not at the front of people's minds. There,
Yeah.
you can say the same sound or the same sequence of sounds, and two people anywhere in the world can interpret that exact same sequence of sounds differently. Meaning that the definition of those sounds, depending, there are words that sound the same in two different languages. Like, for example, the word all in English versus all in Arabic or Muslim culture means two different things, technically, or maybe they mean the same thing, technically. So, quite an interesting way to play the interesting word games that can be played, right? And so,
Yeah.
all in all are two different, quote unquote, conventionally understood words, but technically, maybe they mean the same thing too.
I always talk about that, language and, you know, words and definitions and stuff, because, some people, they use words that they don't really understand for a narrative they want to create. And if you question them on it, like, hey, what is this? Or, what do you mean by that? They get kind of offensive. And if you, like I said, if you just stick to the origins of what the word is, or at least explain why you're using that definition, I think it'll be much easier. Because, not too many people talk about sea electrolysis out there. I don't think I've ever heard it before you. I mean, I've heard of, energy. I've heard of, the pyramids once being under the water and they finding stuff inside there. I mean, I've heard all kinds of things,
Yeah,
but I've never heard what you shared, and that's why it's interesting to me, because you take a lot of what you share and you just, tell people, hey, this is what I think based off of my experience and what I know. It's no different
yeah,
than like what I do. Is that if I tell somebody something, is usually coming from a book that I've learned. I'll distinguish between the two if it's just me coming up with a theory or
yeah.
what I've read.
So, one of the major problems with this is that there's no real class or school you can go to
Yeah.
learn how to reverse engineer advanced technology. So what one of the things that becomes difficult about this is that you have to have a foundational level of knowledge and principles in order to reverse engineer advanced technology. And so I kind of want to demonstrate how you can do that though. And so my focus areas right now are the Grand Canyon, the Giza pyramids, the Taj Mahal, and I'm hoping to add Southeast Asia to my collection. But
Hmm.
maybe since I'm screen sharing, I can screen share what I'm talking about at the Grand Canyon. and kind of build up this idea of how you can start re-looking at what's going on around the world everywhere over and over again. So I want to show some things that demonstrate inconsistencies from conventional narratives in a pretty basic way. So this is a picture from the south rim of the Grand Canyon. And in case you don't know, the narrative of the Grand Canyon is that the Grand Canyon was formed over millions of years, and it was a process of water erosion that happened from the top down. And this water erosion pattern that you're seeing in the Grand Canyon, which is this that I'm showing on the screen, this kind of pattern is all over the Grand Canyon, stretches for miles and miles. But one of the problems with this is that this erosion pattern, so-called water erosion pattern, doesn't exist anywhere else in Arizona. And so one of the things that Randall Carlson presented at the Cosmic Summit was that everywhere else in Arizona except the Grand Canyon is showing water erosion patterns on all their rocks that are consistent with heavy rainfall. And everywhere, every major culture, every major religion seems to have a great flood story of some kind, right? And because of this, we also have some kind of idea on how to date the flood myth. Maybe it's a little bit inconsistent, but on a scale of millions of years, we have some rough idea of that where it is. And another issue is that we have the Younger Dryas impact theory. And again, maybe some controversy over exactly how it happened, but it's clear that some sort of big event like that happened around 10,000 BC, 12,000 BC, 8,000 BC, whatever number you want to put to it, somewhere there. And so this is a period where a huge number of ice caps started to melt. So what I want to demonstrate here is some issues with the Grand Canyon relative to the narrative. So this the water erosion pattern that's happening at the Grand Canyon that is inconsistent with heavy rainfall, and I'll explain why that'll be relevant in a minute. But just to set it up here, inconsistencies with heavy rainfall water erosion patterns, or water erosion patterns that have a direction of travel which would be required for a water erosion pattern, a water erosion that happened top down from heavy river flows. Inconsistent with that are, if I move my mouse here, you can see my mouse, right? Like you can see my
Move
mouse
it. Yeah, yeah, it's in the middle, right? Yeah, I can see
right
it.
there.
Yeah,
Yeah.
it's in the middle. Yeah. Mhm.
So notice these parallel lines that are carved into the rock over and over again. Notice these flat shapes, flat rectangular shapes. Notice that these have regularly spaced waterline grooves, so-called waterline grooves. These are regularly intervaled, and they're basically vertical. I'm not saying they're perfectly vertical, but they're generally vertical. These are all inconsistent with a water erosion pattern related to heavy rainfall. And now what I want to show is what is classically understood as heavy rainfall water erosion. So here, let me move this over. Uh-oh. Sorry, technical difficulties. I got it.
I just saw the bird, the owl, I think.
It doesn't want to go over to this screen. Okay, there we go. Um, this is a picture of the perimeter wall of the Sphinx.
Mhm.
So the perimeter wall of the Sphinx is showing a water erosion pattern that is classically understood to be related to heavy rainfall. And one second here, I think I'm messing up my screen here, so let me
Yeah,
just fix it a little bit.
yeah, I keep seeing that owl pop up.
Yeah, sorry, I don't know why that keeps coming up. That's my background. Oh, okay, I get it. That's my background. Got it. So here's where you look at a water erosion pattern that is consistent with heavy rainfall. Heavy rainfall water erosion is characterized by smooth shapes, rounded edges, and irregular waterline grooves. And you can see this all over the perimeter wall of the Sphinx in Egypt, right here. You can notice very clearly the difference between this and what's at the Grand Canyon. And I understand that the Grand Canyon's narrative is not saying heavy rainfall. I'll get to that in a minute. But I just want to set this up. So you can see how there's not really clean rectangular shapes. You're not going to see a flat rectangular shape, and you're not going to see uh, irregularly spaced waterline grooves. And one thing to note here is that the waterline grooves, if you see a big waterline groove, especially a thick one, you'll usually see one connected to it on the layer below, because that's how water flows, obviously. And you'll also see that the waterline grooves are regularly diagonal. They're not just vertical. You'll see they go in all different directions, right? Just the flow of water. However you think of water, that's how it's supposed to look. So when you go back to this picture that I'm showing, this is too heavily formed, predefined. And one of the other issues is that the waterline grooves are rarely connected to each other on these parallel lines. And again, parallel lines in nature is also hard. Everything about this is hard to do in nature. Clean rectangular shapes, flat surfaces regularly, parallel lines, consistent, regularly spaced vertical lines. All of this is hard to do in nature, especially stretching for miles. You can basically take a picture anywhere in the Grand Canyon and you'll be able to see this kind of or so-called water erosion pattern. So this is stereotypical of what you'll see at the Grand Canyon in the top half. But this is also problematic because it's not what you'll see elsewhere in Arizona. Everywhere, like Randall Carlson was showing at the Cosmic Summit, everywhere else in Arizona, you see water weather erosion patterns that are consistent with heavy rainfall, which demonstrates the rounded edges and so on, more similar to what you see at the Sphinx, not this. So the other big problem is that at the Grand Canyon, you also keep seeing these pyramid-like structures there. And these pyramid structures are not just one or two, there's dozens of them that are known. And so this one's a pretty clean one. And so another issue is that if you are looking at a water erosion pattern where there's a body of water like a river flowing through it with a direction of travel, this kind of structure becomes really difficult to achieve. So if you had a direction of travel for water, let's just pretend that this pyramid looking thing was a giant rock at some point long ago. Then the way that you would expect a water erosion pattern to happen, let's just pretend that the water is coming from diagonal right to left. The way it would look is more of a teardrop formation if it was water carving through the Grand Canyon with a direction of flow. So you would not expect to see a flat face on one side, then a corner, then flat cut edges on the sides, and then somehow flat cut the back out. And also, another big issue with this is that it's creating a step pattern form. And this so-called water erosion pattern is only in this area. This kind of water erosion pattern, the water flow doesn't just happen in this spot and nowhere else. So if this type of water erosion pattern is happening here, you would expect to see this water erosion pattern elsewhere around it as well. But you're not seeing that, especially on the, you can see the cliff structure behind it doesn't have anything close to that. And that's at roughly the same height. So there is no such thing as having a unique water erosion pattern localized to one spot and then not seeing that, especially with a massive amount of water, as the narrative says, and then not see a water erosion pattern similar to that right near it somewhere else too. So all of this stuff starts to make the Grand Canyon look really suspicious. Like, what is going on here? How is that possible? So here's another picture of the Grand Canyon. And here again, you can see some interesting features.
Yeah.
If you zoom in, you'll start to see this regularly spaced rectangular shape over and over again. You'll see this
Mhm.
step pyramid form with parallel lines, right? And kind of interesting, it even looks like there's a pathway carved right here going to whatever this structure was supposed to be. And I don't like this picture just because of this like pyramid looking thing right here. I like this picture because it demonstrates two different kinds of water erosion patterns at the same time. So if you look towards the bottom, now you're seeing the water erosion pattern that is consistent with heavy rainfall. You get away from the rectangular shapes, it's going to be rounded edges. Irregular waterline grooves, smooth edges, irregular waterline grooves and smooth shapes. But that's at the bottom. And so what really flips all this on its head, everything about the Grand Canyon on its head, is that the water erosion pattern that is consistent with heavy rainfall is found towards the bottom, but not at the top. And again, the narrative about this is that the Grand Canyon was carved over millions of years, which means that the top portion of water erosion is supposed to be way older than what's at the bottom. Now, if you know anything about rain, right? Rain doesn't just happen right here. Rain happens everywhere, especially when we're talking about great flood myths and massive rainfall all over the world.
Yeah, yeah,
So,
yeah.
so that is interesting because, as I was saying earlier, there's something wrong with our timeline because the heavy rainfall water erosion pattern is supposed to happen relatively recent in history. So we can argue about the specific date, but you're never going to get anyone to say that heavy rainfall water erosion was millions of years old. No, that great flood myth and the younger dryas impact theory and all this stuff is relatively recent in history relative to the narrative, and it's only down here, but not up here. So that's really suspicious too. And now the Y Files has done a lot of kind of documentation about the Grand Canyon, and I highly recommend people go look up the Y Files Grand Canyon episode. But you'll also notice, just like I was saying before, if you go to the wrong place in the Grand Canyon, you'll see Black Hawk helicopters flying around. And one of the other big problems with the Grand Canyon is that the overwhelming majority of the Grand Canyon is blocked off. There are road structures built all through the Grand Canyon, but
Uh-huh.
the places that you can go are heavily predefined, normal tourist locations, and then most of the road networks are blocked off for some reason. No one, it doesn't really make sense to me why. And the only way to really go out into the Grand Canyon to these other locations that are not just the normal tourist places is to go by foot. And again, you'll see YouTube videos all over the place about Black Hawk helicopters flying around in the Grand Canyon, especially when hikers go to the wrong place. And hikers are finding all kinds of stuff there too. There's YouTube videos all over the place about weird stuff at the Grand Canyon that doesn't make any sense. Megalithic block structures, caves that are built up, all kinds of stuff. So that's pretty interesting. And we do know that there are hundreds, maybe over 1,000 pyramid structures in Mexico. And we do know that Arizona used to be part of Mexico long ago. So it's not that much of a reach to believe that there should be some sort of pyramid somewhere in the southern portion, really close to Mexico. If they exist in hundreds or thousands in Mexico, why wouldn't there be at least one or something near Mexico?
Yeah,
So,
yeah,
and
yeah.
this picture is just to kind of show that the pyramid structures in the Grand Canyon are not uncommon. They're all over the place. Dozens of them that are known. And another interesting thing is that the people who they're like they started like naming a lot of these structures or naming kind of like certain aspects of the Grand Canyon. And a lot of the
Mhm.
names that were originally given to them are like Shiva Temple, Vishnu Temple, other names like that, because the appearance of a lot of the kind of structures in the Grand Canyon look or resemble a lot like Indian temples. And so some of the
Right.
naming even just comes from that from long ago. So
Interesting, interesting.
yeah, I mean, I think that there's a lot going on in the Grand Canyon. And I think that water erosion has a lot to offer. I think Robert Schock has done a lot of work on the weather erosion pattern around the Sphinx. And you gotta be honest, like what he's saying there is pretty basic stuff. That's not hard to understand. That water erosion
Mhm.
pattern around the perimeter wall of the Sphinx is heavy rainfall water erosion. And
Well,
there's some
let me ask you this. What do you consider heavy rainfall? Is it the size of the raindrops? Is it how hard it hits? You know, what do you consider
size
heavy
can play a
rainfall?
role in it, but really it's about the sheer quantity of it.
Okay, just the sheer quantity.
Yeah,
Okay,
massive
so
quantity.
the amount at one time then.
Yeah, it would have to be a lot at one time. I mean,
Okay.
that's the amount, the quantities that would be required to do that are pretty intense. And I want to show another. example of something that I think fits heavy rainfall water erosion. Let me see if I can get a good picture. I should have had this up before. Sorry. Um, yeah, here's one. Let's see if this will come up. This is also pretty. This is Kailash Temple in India. If you don't
Mm-hmm.
know about Kailash Temple, in my opinion, like everyone should know about Kailash Temple. This is a pretty nut structure. And to give a little background on it, it's just it's a uh, temple structure in India that's carved in basalt, and it's carved into the side of a mountain, and it's carved out, but it's one giant megalithic stone piece. The entire structure, the entire complex, is one giant stone piece, and it was
Mm-hmm.
carved by carving out the negative space from the top down. So what you're looking at here is a lot of erosion that happened to the Kailash temple, and the Kailash temple is dated to somewhere between 1000 to 700. I guess they're saying 773 AD here, but the more common dates I've seen are like 1000 AD. So well after the periods where we know massive amounts of rainfall would have come. But we're
Okay.
also noticing just huge amounts of erosion that looks like, again, water erosion from heavy rainfall. And so that would be
Mm-hmm.
difficult if there isn't a heavy, like something enormously substantial to generate. This is basalt, it's very hard rock, it's close to the hardness of granite. So in order to this is not just going to be like some water flowing over it and it'll carve it like this. It'll do that. No, this is going to have to require a lot of erosion in order to make that this something like this happen. So there isn't really a period of time where enough rainfall would have happened between the dating that they're talking about, even the ones that they're showing on the screen here, and now. There's not enough rainfall that could have happened to generate
Mm-hmm.
this kind of erosion, this extreme and pervasive kind of erosion on the Kailash temple. Not in the past 1,000 years. Yeah. So water erosion has I think, a lot to offer, and since I'm kind of talking about a problem with the timeline,
Mm-hmm.
I think the Great Flood myths and the Younger Dryas impact theory, they can be tied into ancient archaeology because they do provide a pretty significant timestamp that can be confirmed in the geologic record about when something like that could have happened. Something of
Right.
that level of extreme significance, extreme presence for water erosion.
That's interesting. So, and that's why one of the questions I wanted to know was, or answers that I needed to know from you was, what do you consider heavy rainfall? Because I'm trying to understand how. Okay, wouldn't it fill up? Wouldn't it flood over time if creating like some kind of what you call it, like some kind of pond or a lake or something like that, or a river that it possibly could build? Because you're saying this, the water is hitting it hard, right? And it's hitting it hard at a very quick pace, right?
And huge
So
volume.
where would the water go? Where would it rest at if it was heavy? Where do you
Yeah,
think it would
I mean,
go?
it would have to have a drain off. And
Yeah,
if you kind of go along with the idea that I'm proposing here, the heavy rainfall is at the bottom. So what
yeah.
that means is that this area was carved out first. And then if the timeline is messed up and there's none of that water erosion at the top, well then what that means is that this stuff came after, not before.
And that was the softer type water, right? The one that took much longer than possibly, right?
What do you mean by that?
Like, was it do you think it was heavy rainfall also for that portion? Like some type of heavy rainfall, just like what would you rate that when you say heavy rainfall for the bottom? What would you rate the top part?
So the top part here does
Hmm.
not demonstrate any consistency with either heavy rainfall nor water with a direction of travel. Neither narrative
Gotcha.
makes sense with this right here.
Okay.
So that's what I'm saying, is that maybe you can make an argument that there is water with a direction of travel here. Maybe. It's not my opinion. In my opinion, it'll be actually heavier rainfall makes these vertical curves like this.
Mm.
And you can see heavy rain runoff, kind of runoff looking appearances. So that's the not anything that seems to show that water had a direction of travel, and that's where you'd get more angular curvature if it had a direction of travel. So because that's down here and not up here, like you would expect to see the heavy rainfall up here. So what that means to me is that all this stuff that happened up top came after, not before.
Mm.
And that's the crazy part. That's the part that flips everything on its head and tells you that something's wrong with our timeline.
Yeah, because you said that the top should be older and the bottom should be younger.
Mhm.
Yeah,
Yeah.
yeah.
Well, I mean that's how it's supposed to look. But the younger portion of the water erosion, if it's a heavy rainfall because it's vertical grooves like this and not angled for direction of
Mm.
travel, then it's not like rain just happened here. Rain's supposed to happen here too. So this is
Yeah,
supposed
right.
to be a universal water erosion pattern. And by the way, another thing that really makes this difficult to even accept is that this water erosion pattern, so-called water erosion pattern, that's very stereotypical of the Grand Canyon, and as you can see, it's everywhere. Everything back here is this. All of that water
Mm.
erosion pattern doesn't exist anywhere else in Arizona. It's all this stuff, rounded edges, not this. Has anyone else in Arizona seen this water erosion pattern anywhere? I haven't. And I live here. But I see this kind of stuff everywhere. I go to Sedona, it's this. It's rounded edges. It's all over the place. But not this. And that's the other thing that's kind of unusual is that no one in the mainstream kind of narrative has taken any interest in the fact that this is a water erosion pattern that only happens in the Grand Canyon and nowhere else. And why are there two different kinds in the Grand Canyon and nowhere else? Yeah, that should be of significant interest to people, especially because what looks to be odd and suspicious is the frequency with which the government gets involved in archaeology everywhere in the world. And
Hmm.
I was bringing up like Hitler's huge prerogative was archaeology. A massive amount of
Hmm.
his prerogative was archaeology. And it's unfortunate that he stole the swastika.
I want to know why they do have, you know, government vehicles going in and out of that area. And sometimes I just think because, of course, it's secret bases. I mean, people probably know about them. They just can't go there. Secret laboratories and stuff like that.
They put a secret base inside a national park and
I
inside the
mean,
Grand Canyon.
why not? It's federal owned, right?
They did it during the Roosevelt era. That's when they did it. Yeah, they made it
Yeah.
federal park.
Yeah. So as long as it's federal, they can do whatever they want. That
They can.
maybe,
Yeah,
you know,
yeah,
buy up the land and call it federal, and boom, that's
yeah,
you know
yeah.
we get these
Uh,
theories. So, oh, go ahead.
I'm not going to say that there isn't a base in the Grand Canyon. Yeah, probably, especially considering the frequency of the Black Hawk helicopters that they see there.
Yeah.
All I'm trying to say, any one data point is not relevant. But
Yeah.
when the data point becomes thousands of data points all over the world, every single time you go and try to do anything like this, yeah, then that becomes a problem. Yeah. And part of what I'm trying to do is I'm trying to do pattern recognition on megalithic structures to prove that they're related. And so another major element that is common and frequent with megalithic structures everywhere in the world is that water is a significant element of their design. They
Hmm.
are commonly and frequently incorporating water into the megalithic structure design and the areas around it. So it's often artificial, it's not natural. It's well understood that many of these water bodies are artificially created around these structures intentionally. Examples of this are Angkor Wat. Angkor Wat has huge water reservoirs. Here, maybe I should show Angkor Wat. That's just worth seeing if you haven't seen it. The area around Angkor Wat is just covered in water, and is the not only is there like this giant moat that's around Angkor Wat, which is like one side of this moat is like a mile long, but also there are massive water systems that are artificially created all through the area surrounding Angkor Wat. artificially created water systems networked all the way through, kind of like you were doing irrigation and water transport for some reason. And artificial. Taj Mahal is another example. It has a body of water right behind it, and it is known that there's a body of water that was artificially created underneath the Taj Mahal. And I'll talk a little bit about that too. So that's also interesting. Chichen Itza, same thing. Machu Picchu has a body of water around it. I think they're finding at Teotihuacan and underneath Mexico City, even they're finding water networks underneath it. And then on top of that, just recently, what I was saying about Trevor Gossi, he's looking at tunnels, all kinds of tunnels underneath the Giza Plateau. There are water reservoirs all around the Giza Plateau. And what they're talking about is they're also seeing that there's a water table like 100 feet underneath the Giza pyramids. So water is commonly found around these megalithic structures. And so one of the things I was saying before is that we need to have engineers from numerous different disciplines looking at these megalithic structures, because the people who designed these structures incorporated numerous advanced principles into their construction at the same time. And this is inconsistent with the idea that this was a barbaric culture or a primitive culture. They are demonstrating advanced math, geometry before we ever figured it out. They're describing advanced astronomy, and the mythology is good at astrology, but the astronomy long before telescopes were invented. And then they're advanced in civil engineering. So advanced acoustics engineering is another common thing that has happened.
Binary obliques and stuff. Yeah.
Yeah. In fact, I want to kind of show the Chichen Itza video. It's really
Yeah.
short. Whenever I try to share this on my screen, it doesn't work because the audio doesn't come through. So maybe it'll work if you do it.
All right. Yeah. Send me the link.
Okay. Let me figure out how to get it, because my screens are a little bit off right now. So I'll send this to you, and hopefully we can just play it, because you'll just describe what I'm talking about way better than I will, and it's easier with the visual.
You sent it to me in the private. There we go.
Yeah. So if we just want to play this, and I just want to demonstrate that acoustic engineering is also another common principle that is applied in the engineering of these megalithic structures. Not just this one. We're finding acoustic tuning everywhere. We're finding it at the Taj Mahal. That Taj Mahal is acoustically tuned. The Giza pyramids, the Grand Chamber and the King's Chamber is acoustically tuned. And again, many megalithic structures are acoustically tuned.
I know exactly what you're talking about now. When they're doing their clapping. Yep, I know what you're talking about now.
Yeah.
Yep.
It's pretty cool to see. So it's just worth, if anyone hasn't seen it, it's totally worth seeing.
Yeah, let's see.
This,
can you hear it?
This is a simple echo. Okay. Actually, it's simple to explain. When you clap in front of a pyramid, of a slope, the sound will go to the top. In this case, a pyramid. You know? And if it's there a cavity or a temple, like in this case, the echo will come back to you. If you clap in front of an Egyptian pyramid, nothing happens because the sound goes away. But here, the sound comes back. Why it sounds like a bird? Don't ask me that, because we don't know. But this is really impressive. Experts from different countries, experts in acoustic, have come here to study, to try to know how this is possible. They leave the country just like they.
It works all four sides the same.
Used to be. Now only two. Yeah, the north and the west. You see? This.
Yep.
So yeah, I just subscribed too, because I'm gonna go back and look at that channel.
Yeah, great short little video that demonstrates advanced engineering. Yeah. So it's one of the problems with all these narratives around the world about these structures. One of the things, if you're an engineer, you understand very clearly that precision is high effort. Precision is not an accident, especially precision happening thousands of times around the world. So one of the things that's kind of difficult to get through with engineering arguments is that precision in the common narratives is often trivialized or dismissed as easy or not really that relevant. No, that's not true. In engineering, you understand the more precise you want to be, the more extreme that difficulty is. It gets exponentially more difficult the more precise you are. And the level of precision that they're going for in a variety of these megalithic structures is extreme. So I'll talk a little bit about that. The civil engineering aspect demonstrates this quite a lot, and that's going to be Ben Vanderwick's work, and Chris Dunn has talked a lot about it, and others. But before I get to that, I want to rep Phoenix, Arizona, just a little bit more because there's something else cool worth seeing here. So you may have heard of the famous architect Frank Lloyd Wright. And Frank Lloyd Wright was also he built some things all over the country, but he also built some things in Phoenix. And there is a hotel in Phoenix, Arizona, that's called the Arizona Biltmore Hotel. And in this Arizona Biltmore Hotel, there's a room there called the Aztec Room. And in the Aztec Room, I'm screen sharing if you want to show. So this Aztec Room was in part
Yeah, I had to bring.
by,
I was trying to bring it up, bro. If for some reason it wouldn't, it kept saying I had to close out all my other tabs that I had open.
No, you're fine. The Arizona built this Aztec room was in part designed by Frank Lloyd Wright. And Frank Lloyd Wright, back in his time, he was heavily interested in all these megalithic structures. He studied Chichen Itza, the Giza pyramids, and so on, all this stuff. And so in this room, there's this beam structure going around the room. It's a circular room. And in the middle of the room, there's this structure right here in the middle of on the ceiling. And if you stand underneath this structure and you talk normally, then it sounds like you're speaking through a loudspeaker. And so these beams that are around the perimeter of that structure in the room, these beams, I want to make the argument that these beams are related to sound amplification, acoustic tuning. And I want to introduce this structure right now because this is going to come up later when I talk about the grand chamber in the Khafre pyramid. Because Chris Dunn has done some work on this with Helmholtz resonators, and it looks just like this. And I just want to demonstrate that this sound amplification technique has already been demonstrated in real life. And you can go to the Aztec Room in the Arizona Biltmore Hotel in Phoenix, Arizona, and you can see this working for yourself. You don't need to take my word for it. So that's pretty cool. I want to get into the Giza pyramids a little bit. So the first thing we need to talk about is what is saltwater electrolysis? Because it's a very simple reaction, actually. And you know, this electrolysis, just as a chemical reaction in general, is pretty basic. In general, what electrolysis does, so this is just running a current through your solution. What electrolysis functionally does is it separates the individual components of the solution. And all you need in order to do saltwater electrolysis is all you need to do is run a current through the salt water. That's it. That's the whole chemical reaction, a whole process of inducing the chemical reaction. So it's a relatively simple reaction. And salt water, another way of talking about salt water is seawater. Seawater is salt water, same thing. And so the chemical reaction for saltwater electrolysis looks like what I have here on the screen. This is a very simple video. If you want to watch it and learn a little bit more about it, it's really short. And so saltwater, salt is sodium chloride, NaCl. Then you have the water, H2O. And if you run an electric current through salt water, you'll break apart the sodium and the chloride, and you'll break apart a hydrogen from the H2O. And what you'll get is you'll get sodium hydroxide. They'll recombine into sodium hydroxide, and then you'll get H2, hydrogen gas, and chlorine gas. And now this is going to be really important. So very simple reaction, right? All it is taking the salt, literally salt, sodium chloride, and breaking it apart, and you'll get sodium hydroxide, a basic, slightly basic substance. Its properties are that it's a known detergent. And then you
Mhm.
also generate hydrogen gas, which will be important, and chlorine gas, which will be important. So keep this in mind, very simple, and I'll show how this might apply to the Khafre pyramid. So I like this diagram. My explanation. This is someone else's diagram, and they have their own version of their own theory. But I like this diagram because it kind of just shows some pathways in the Khafre pyramid, and it'll be easier to understand what I'm talking about. So what we here, let me just talk about the basic things that we do already understand about the Khafre pyramid. We do understand that there is a number of water reservoirs all around the Giza plateau. We do understand that long ago, around the time when the Giza pyramids were supposed to be built, that the area, this area in Egypt was very lush, very green, very fertile at that time. We also know that there was a river that branched off of the Nile River and came by this area. And so we already know that there could be a source for seawater, simple seawater, and we have water reservoirs. And there's also a structure, an outline of a water reservoir outside of this entrance right here. So this is a descending passage that is known in the Khafre pyramid, and this descending passage has a water reservoir right here. So also in this subterranean chamber, maybe I can make it a little bigger. In this subterranean chamber, and then up into this queen's chamber, it is well understood that there are a lot of salt deposits. And especially in the subterranean chamber, when you look at the old photos, it looks like salt deposits are pretty heavily caked on there. And so if you wanted to, if just logically thinking, if you have a water reservoir here with an entrance that is descending, what does a gravity fed system for water look like? Seawater. So if you have seawater going down this descending passage, it can be a gravity fed system, and it only needs to be, the water reservoir on the outside only needs to be at roughly the height of the queen's chamber in order to fill this area up with seawater all the way up to the queen's chamber. That's just gravity alone, nothing else, from the water reservoir that would be out here. And so if you filled this up with seawater, then of course you would see seawater, salt deposits all over the place. And you also do see salt deposits up here in the queen's chamber. So what I'm proposing is that there is this descending shaft is literally for bringing in seawater. And the purpose that I'm going to describe for why they're bringing in seawater into the Khafre pyramid is for water filtration purposes. So on Christopher Dunn's team has found clams in the subterranean chamber as well, again indicating seawater entrance and not just any water. So what I'm proposing is that there is a heated system that's happening here. There's a whole room in the subterranean chamber that's engineered on the side. And in my opinion, there's a heating structure that's in there. I'm not going to be able to prove that right now. I'll talk about the granite boxes a little later and explain some of that. But just for suffice for now, to avoid a lot of detail, suffice for now that there's a heating system here. And the only purpose of this portion of the subterranean chamber here, the only purpose, in my opinion, is just to heat the water. And this is acting as a initial filtering mechanism just to get rid of large particulates. We even know underneath the subterranean chamber, there's another like shaft, and it looks like it would be an easy place to dump large particulates like debris and stuff like that. And I think the only purpose here is to heat the water. There's something called a countercyclic vortex that you can create here, and there's shaping on this divided passage right here. So there's a passage, the descending passage goes down, but then there's a split off here that goes up, and this is called the well shaft. But there's also shaping on this splitting, and it indicates that the shaping indicates that there's a countercyclical vortex here. What that means is that you'll have ambient temperature water coming down from the outside, and then if this is heated, you would have hot water going the other way, and you would create a countercyclical vortex. The cold water, the ambient temperature water, would be rotating clockwise as it goes right to left, and it would be on the interior of this vortex. And the hot water would return counterclockwise, left to right, going on the outside of this vortex. So cold water clockwise, right to left in the inside of this vortex, and then hot water counterclockwise, rotating on the outside of this vortex. And the rotating outside hot water would be the one that would be prioritized going up this well shaft. And again, this is all gravity fed system. You don't need anything else. Gravity does this as long as the water reservoir is filled up to here. So once you have water reaching the Queen's chamber, in my opinion, this is where the saltwater electrolysis process can begin. And so I want to talk a little bit about these granite boxes. I accidentally closed the tab that had the boxes. Give me 1 second.
No, that's actually pretty interesting. So I know you can't see my mouse. So on that entrance of that pyramid, that's where the water would need to be at?
Yeah, that would need to be there. And I think there's a reason for why they put that up there. They wanted to wait for the water reservoir to fill to a specific height and then allow it to go through. And what I'm going to eventually get to is that this is going to be a highly controlled process. They're demonstrating over and over again that they are controlling this process very, very tightly. And that's a good thing. That'll be a really good thing as we go through this more and more. So I want to show the Serapeum. So there is this thing about granite that is being used in megalithic structures in Egypt. And something to know about granite. Granite is a very hard rock. It rates somewhere around a 6 or 7 on the Mohs scale. It is way harder than copper, which at the time period that they're saying that these structures were built, they would have only had copper tools. So if you try to cut granite with copper, which copper is way softer than granite, you'd be shaving off copper at a massive rate. And so at the Serapeum, they have these giant granite boxes all over the place. Not just one, many of them. In fact, they have 24 of them. And so this is a combination of Christopher Dunn and Ben Vanderwick's work. They've been looking at how is it possible that they cut these massive granite boxes, megaton granite boxes. So some of these boxes are close to 15 feet in length on one side. That's insane. That would put these boxes well into the megaton range, 20, 40, 60, 80, maybe even up to 120 tons. That's how much we're talking about here. So these granite boxes, Christopher Dunn's team has looked at this and they compared the rate at which you could cut a granite box with a copper saw versus a modern day diamond tip machine saw. And so if you cut a granite box with if you cut granite with a copper saw, you can go at an average rate, best case, 3 millimeters per hour. And that's how, and that says nothing about how you're shaving off the copper as you go. Now, if you use a modern day diamond tip machine saw, you can cut granite at a rate of 30 millimeters per hour, nonstop going at that rate. So in order, I know it's a little bit less than 15 feet, but let's just round to 15 to make the math easy. Just to make one cut with a diamond tip machine saw 15 feet long into these boxes with a modern day saw, that would take more than 6 days straight, 24/7 cutting in order to make that one cut. And that says nothing about the depth of the cut, just making a 15-foot cut into a granite box like that. So in order to do it with copper, that would take roughly 10 times longer than the modern day machine saw. So
but do you think do you think but it could be done though, right? Is what you're saying, is it could be done. It'll just take a long time.
It can be done. I'm getting there.
So so they could be working on these while they're still building the pyramids on top.
They could, but here's what we'll get into some of the math here.
Okay.
So there's going to be a few different pieces of math that make this even more ridiculous the more and more we talk about it. So I just want to illustrate, just to cut one side, it's going to take more than 60 days with a copper saw. And then you also have to cut the other side. And then you also have to cut the ends. You have to cut the bottom and the top. And then on top of that, you also have to cut the lids. These things have lids. So you have to cut the lids. Oh, wait, I'm clicking on the wrong screen. Look at these lids. So now you also have to cut the lid, and then the lid has shaping. So now you have to cut each of these shapes on the lid as well. So what I'm trying to make, the argument I'm trying to make here is that the labor intensity just to cut one thing in granite is astronomical. The labor intensity goes off the charts rapidly. And this is not just done one time. These granite boxes, in just the Serapeum alone, there are 24 of these granite boxes. Just the Serapeum alone. That's just one place, one thing. These granite boxes are appearing all over Egypt, tons of them, over and over and over again. And every single time, by the way, they call these things tombs. Every single time. But one of the problems is that these granite boxes are often incorrectly sized to be a tomb. Some of them are this big. The ones that are in the Khafre pyramid are roughly 5 feet long, so a little too short to be a tomb. And these ones are closer to 15 feet long. Look at that. You have people for a scale here. So if that's a tomb, like, what is all that space for? It's very inconsistent, the sizing of these boxes, and often, almost every single time, I think what I've heard is that they've only found human remains in one box ever. That's what I've heard. I haven't heard anyone find human remains in these so-called tombs. The ones in the Egypt pyramid don't have them. The ones in the Serapeum don't have them. But they still go with this narrative that these things are tombs. So this is from an engineering perspective, this is a extreme labor cost intense choice to make. And that is all I'm talking about is the cutting alone. But that's not all they did. Now, not only did they cut these shapes, but they also mirror finished this granite on every side. These are mirror finished both on the outside and on the inside. And then not only did they cut all these shapes, but don't forget, they cut the inside too. And they had to scoop out the entire inside. And that
Yeah,
adds
to
an
do the
enormous amount of
inside too.
time.
Yep, that definitely had to take a lot of time. But couldn't they do the inside and the outside at the same time though? Like, couldn't a group of people be working on the outside and inside? So that might. Yeah.
But I mean, what I'm talking about is the timelines that I'm talking about are 24/7 nonstop. Meaning you have somebody working nonstop. That's how you get to 60 days. I'm giving the most generous possible. And that's just one cut on one side and not even.
Do you think that's possible though? I mean, we have night shift now. We have people working 24 hours a day. Well, not one person, but we always have somebody on duty for 24 hours.
Yeah. So here we go. Okay. So we're cutting 24 of these 24/7, making lots and lots of cuts. But here's the other problem. All over Egypt, and even in the Egypt Museum, there is examples of mistakes where these things were cut. There's one of these granite boxes is sitting in the Egypt Museum, and there's a giant cut in it that's an incorrect cut, and they had to abandon it. So in other words, they were making mistakes too on top of that, which means like a year of your life goes away when that happens. And if you were making a mistake, why did you keep cutting? That's the other thing. Like, why is the cut so deep? If you look at the, maybe I should pull it up. The Egypt, I wonder how I would get it again. Egypt Museum, granite box. Can I get that?
What you looking for exactly?
Oh, looking for this, kind of like that. Yeah. Where they just kept cutting. Like, if you're cutting at 3 millimeters per hour, why'd you keep going? Like, that's ridiculous. How much time did you waste on just cutting the wrong cut over and over again? And they have examples of mistakes all over the place. It's not like there's just one. There's tons of them. I wish I had a clean one of the one that's like in the Egypt Museum. I'd have to dig around for it where they show the backside, because they show the front side easily, but you have to like go all the way around it to go and see the backside, and it's not normally seen. But the wrong cut is done on the backside of the one. Next time I'll have to like go and find it. I don't want to waste too much time looking around for it. But if you want to go find it, you can just go see it. It's not like it's hidden. So that's the major issue, is that these granite boxes are extreme. Whenever there's a decision made at that time period to use a granite box of some kind or a granite block of some kind, that's a major, intense engineering decision that's made. And this is where I want to talk about precision. Christopher Dunn's team and Ben Vanderwyck, and when you look at the stone granite vases from Matt Beal's work, when you combine all of this, they're also doing this at extreme precision. The granite boxes are cut highly precise. The drill work is cut highly precise, and the vases are cut highly precise. So this is when you combine all of this, they're demonstrating that they know how to do precision consistently over and over and over again. And this is the part that gets dismissed by the conventional narratives of the mainstream. They often look at high precision and just dismiss it like it doesn't mean anything. No, we can't even hit that kind of level of precision today. I think Christopher Dunn has asked granite cutters to see if they could make these boxes, and they won't even try. And Matt Beal has tried to find people to make one of the recreate one of these vases out of granite, and he can't even get anyone to do it.
I actually asked him, about that when I was up there at Cosmic Summit. I think it's because the money is not high enough for them to waste their time on it. A lot of things are motivated by money. You offer somebody enough money to recreate those vases, I guarantee, and actually publicize it. See, the only people that really know that are probably just some engineers and just some fans of his and stuff like that. But there's not a mass understanding of these vases. There's not that many people that know that. It's a small group. Like you said before you went to Cosmic Summit, and I've heard this from so many people, including myself, experiencing this. There's not really a group of people that's in your local area that talks about this. You usually find some of your most similar person online. That's how we met. If we would have never met at Cosmic Summit, we would never be talking about this stuff now.
Yeah.
But it's not, the community is very small. So I think that maybe if people get motivated by money, there's even people out there, maybe he's looking for the wrong people. Maybe he's looking for the professionals. Maybe he's looking for probably the people that, do it as a hobby. Somebody like me and you, this is our hobby, right? I wrote a best-selling book based off of my hobby. You're traveling the world and learning all this great stuff. You're even you've done like 5 or 6 podcasts in the last month that I know of. This has caught on since you came from Cosmic Summit. So obviously, the more people that hear about this is a great topic anyway, because people already know there's water under the pyramids. Does that have to play with the part? And then this area is some people consider it a power plant of some sort, right?
Sure.
And you bring in another theory that sounds very, very convincing.
Yeah.
So,
and all I want to say about the precision is that, sure, maybe with enough money, we can get somebody to recreate one. But the issue is that this is the year 2025. And that is pushing even if it was possible to do, which I think Christopher Dunn has approached many top companies in granite cutting. At least he's mentioned this on the Danny Jones podcast, on one that he did about a year ago. He did try to reach out to like hardcore, high level granite cutters to try and cut some of this stuff, and they won't even try. They won't even offer. They won't even give him a price. Let's just put it that way. Maybe it's possible. Maybe it's in today's technology with all the advanced tooling that we have. But look at the time frame that we're talking about, and when they're pulling it off, and when they're doing it, and how many times they're doing it. They're not just doing it once; they're doing it over and over and over again. In fact, hundreds or thousands of times. I don't know how many granite stone vases we found, but there's tons, right? And Matt Beal, and unfortunately, a lot of them end up on the black market and stuff like that. And Matt Beal has been trying to gather a collection of them. But another thing to note is that I'm trying to draw comparisons to megalithic structures all over the world. And I'm trying to imply that these things are related because there is advanced level of application of principles and skills in more than one place. So this advanced cutting that we're seeing in the granite at that hardness scale, I want to go back to what I said about Kailasa Temple. That is another example of extremely hard. It's not quite as hard as granite, but it's right almost there. And they're carving an entire temple structure, an entire building that's huge, massive, an entire complex out of one of these things. Okay, so let's say you can make one granite box as precise as they have. Okay, well, how do you cut out Kailasa Temple then? The entire thing. And by the way, at Kailasa Temple, this is an Indian structure. And if you've seen Indian architecture, old archaeology from India, they are ornately engraved. Every square inch is ornately engraved. They're carving into this basalt like it's butter. Over and over again, we're talking millions of carvings. Well over that.
Oh
I think
man,
some
hold
of
on, man. You
Yeah.
went into robotic mode on me.
Uh-oh.
I think you froze on me.
Can you see me?
Yeah, it's
Uh-oh.
frozen. No, there we
Okay.
go. There we go. We're back in effect.
Okay. Sorry about that. Yeah, maybe my internet isn't so good. It stormed here for like rarely it storms in
Yeah,
Phoenix.
it's about to start storming here now. I'm hearing the thundering here now.
Yeah. So going back to saltwater electrolysis, all you need is to make this thing work is run a current through salt water, and then that reaction can begin. And what's good about saltwater electrolysis is that it's a relatively slow reaction. It can have more than one step. The step that I showed on the screen, where it creates sodium hydroxide, hydrogen gas, and chlorine gas, that's the first step of of saltwater electrolysis. However, if you allow that reaction to continue, there can be a second and a third step, which I'll talk about. So I wanted to bring up those boxes and talk about all that because that every single time that they do that because of the high workload requirement. The entire Giza, the entire pyramid is built out of limestone. But when they moved to the King's Chamber and the shafts of the King's Chamber, they switched to red rose granite. And so that's tons and tons of blocks that is red rose granite. And there's also a lot of, it looks like the floor of the Queen's Chamber was torn out. The original floor was torn out. And so a lot of people think that there was rose granite also in the Queen's Chamber. A little bit more controversial to say that there's rose granite in the Queen's Chamber, but undeniable in the King's Chamber. In my opinion, that there was granite also in the Queen's Chamber. And the reason for that is because I think these boxes are related to an electrical system. And so the smoking gun for this is going to be in Cambodia around Angkor Wat. And so Praveen Mohan just showed a video recently. He just uploaded a video recently showing he found quartz crystal and he found copper wire inside, in the same place, inside a sculpture in the area around Angkor Wat, in one of the sites around Angkor Wat. And again, we know that the Giza pyramid is filled with quartz sand. And so the piezoelectric effect would be an easy and simple way to generate an electrical current. And we already know that there are indications of copper wiring possibly in the Giza pyramid too. This is some of Graham Hancock's work, and both Christopher Dunn and Graham Hancock have tried to indicate that maybe there was copper wiring. There's like a picture that looks like literally a plug that has melted copper wiring coming out of it. So these things exist. And again, I'm looking for patterns that overlay between these megalithic structures because these are all demonstrating advanced engineering. So some more math behind all this. There is an estimate of around 2 million blocks, megaton blocks, used to create the Giza Plateau and the pyramids. So the current conventional narrative is that this whole thing was constructed over the course of 30 years. So Ben Vanderwyck has done the math, and if that's true, then you would have to quarry cut, polish, and shape, deliver, and place one block per roughly 5 minutes in order to achieve that 30-year target. And these are megaton blocks. And you would have to do that 24/7, no breaks. That's like a machine doing that 30 years straight. So just to demonstrate again how precision and extreme effort is often dismissed as being trivial. No, we can't even move 2 million megaton blocks. No, I don't care how much money you have. You're not doing it at a rate of 1 per 5 minutes. You're not going to cut core, do all that. I mean, like there's my background is finance. So there's also another argument to make about civilizations. So again, we are looking at these pyramids, and it's not just the pyramids on the Giza plateau. There are thousands of pyramid structures, just pyramid structures alone, all over the world. And then you add on all the other megalithic structures that are not pyramids. They're not just doing this once or twice, right? Thousands of times. And every civilization all over the world is doing it, every major one. So, what we're talking about, if you're looking at things at a civilization level, they are investing their society into this incredibly intense work for an extended period of time. And they would have to be using the highest level artisan workers to achieve the results that they're trying to go for here. And they're dedicating all that talent for an extended period of time over and over and over again, not just once. They didn't just do it for this 30-year period of the Giza plateau, right? So if you're an advanced civilization that is capable of doing all this stuff in the first place, just what is already known, forget anything advanced, like just to place all this stuff, engineer how to do it all, make sure that it all stays structured, cut all that stuff, get it on the astronomical alignments, do all the math and pre-planning. If you are a culture that is capable of doing all of that, then this is a method of destroying your entire civilization, because none of these structures in the conventional narrative are generating any kind of practical or utilitarian value. And it's fine to dedicate your most skilled workers, your society, to a megalithic project once, maybe twice, maybe you can get away with it 10 times. But you cannot keep doing that over and over and over again for no economic or practical utilitarian value, and then expect your society to advance. You would actually collapse the civilization that way. And this also, at the same time, it does not demonstrate a culture or a civilization that values technological progress. Because the whole point of technological progress and understanding all of these principles is to apply them and control them and use them. So one of the other issues is they have already physically demonstrated understanding of these principles. So if it's true that they were able to make these structures and apply all the math and all this stuff to do this, it is not fair to say that they only applied those skills for this purpose and nothing else. The only reason that they learned this stuff is to build tombs and then never use those understandings or principles for anything else. That's ridiculous. That's just completely absurd. No. If you understand these things, and so there's something that should be said about academia. And academia, I think, does understand this. Academia understands that theory is difficult, can be difficult, but the application of theory in real life is at least 10 times harder than the theory of it. So it's not just that they understand these things. They understand them well enough to apply them. They understood the Chichen Itza pyramid well enough to apply acoustics. And that means that they don't just understand the principles of it, they know this at a deep level, and they were able to demonstrate it in real life. And that is even harder than just understanding the principles of acoustics. And so this is another part of where I'm trying to say that the conventional narrative frequently dismisses precision work and advanced engineering as easy or trivial. Yet we don't have the ability to easily do this in modern day. Maybe you can make an argument that we could do it if we put enough effort behind it. But they keep doing it over and over again. And the demonstration that they showed at Chichen Itza is basically a party trick. They're doing that as like for fun on the outside. The stairs has to be engineered exactly right, because if you mess up the spacing on the stairs, it won't sound right. It'll sound off. It'll sound it won't sound like a bird. In order to get it to achieve the sound of a Quetzalcoatl bird, like what they're doing there, you have to get the spacing just right. Otherwise, the sound waves will distort and you won't get it right. So again, precision work and pre-planned, not an accident. And so again and again, acoustic engineering is dismissed, not recognized. Yet this is examples of high precision engineering work that has to be pre-planned. It requires not just understanding basic principles, but when you apply it in real life, that's way harder. And again, we're seeing them apply this not just in one localized place, they're applying this concept around the world. Over and over again, megalithic structures are demonstrating acoustic tuning, and that should not be dismissed as something trivial. And so, again, the narrative is that these people are barbarians and they didn't really know much, and everything is about death and tombs and all this stuff. No, it's not. We got to get away from that. This has happened too many times, and it's not a coincidence. So, what I want to show, to go back to saltwater electrolysis, the advantage of saltwater electrolysis, and I want to make the argument that the boxes that we keep finding at these places are related to an electrical system. And I believe that there is one box that should be here in the Queen's chamber. But as I've said before, it looks like they removed the floor and it used to be granite. And there's indications of a lot of work where they had taken stuff out. I should also mention, by the way, that there isn't a reasonable way to get the granite box that's in the King's chamber. There isn't a reasonable way to get the granite box into the structure. They would have had to put the granite box in there first and then build the structure around it afterwards. This is another problem at the Seraphim, where they have 24 of these giant granite boxes just there alone. And again, those granite boxes there's no reasonable way to transport them after the structure is already built, because they don't fit through the passageways. In other words, they would have had to build those things first and then build the structure around it afterwards. So it creates, we're creating layers and layers of problems that require advanced engineering solutions. These are not barbarians. Barbarians can't figure this stuff out. So the advantage of saltwater electrolysis is that you create chlorine gas in the water. And now chlorine, you must know you would know from pools and stuff like that chlorinating water is one way of killing microorganisms and bacteria and stuff like that, chlorinating water. So saltwater electrolysis is now demonstrating two advantages for water filtration. Number one was the sodium hydroxide, which is a known detergent, and that'll help kind of clean out the water. Now we have chlorine gas that is being bubbled as a gas. So the sodium hydroxide is particulate form. It'll be in the aqueous solution. It'll be solid matter in the aqueous solution. Chlorine gas will be bubbling through the water. And then you'll also be generating a hydrogen gas. So in this if I'm right, then in this Queen's chamber right here, there will be in the headspace hydrogen gas and chlorine gas that's being created. And now Christopher Dunn's team has found hydrochloric acid residue in this Queen's chamber, and I believe he's also found it in the Queen's chamber itself, in the Queen's chamber shaft, the south end, I believe, and in the Queen's chamber itself. And so what I want to argue is that in the second step of saltwater electrolysis, if you allow this reaction to go for a long period of time, it's a slow reaction. It'll take more than 24 hours or so to develop into the second step. If you put this system under high pressure, which, by the way, if you're having hydrogen gas fill into the headspace, you're creating a high pressure system. So if you have a high pressure system that's filling with hydrogen and chlorine gas in this south chamber, you'll be able to fill that gas together. And as it reduces to a lower energy level over time, hydrogen and chlorine will come together and you'll be able to generate hydrochloric acid. And so there aren't too many ways to create hydrochloric acid. There is more than one way. This isn't the only way to create hydrochloric acid. But what I'm trying to say is that this is a simple way of creating hydrochloric acid. And the fact that we saw hydrochloric acid residue, Christopher Dunn's team has found it in this chamber, means that we can narrow the possibility space of what was going on here. So to me, the hydrochloric acid is a significant element of evidence that we've already confirmed and found. And I hope that more people get onto that. By the way, I want to give a shout out to Land of Chem, because Land of Chem has been the guy that has like really taken the chemistry aspect of understanding these things to another level. And I think what he's found is the southern pyramid on the Giza plateau is probably generating ammonia, and ammonia is very good for producing fertilizer.
Man, bro,
Yeah.
do I have the book? Where's that book at? Oh man, I put it back up in my library bookcase. Look, there's this guy. Dang, I can't remember the title of his book off the top of my head now, but his name is Ken Goodsworth, and he actually talks about that in his book. So I have to. Oh man, I just had it yesterday too because I was looking through it. But yeah, he found like he found like these chemicals inside these pyramids, and he talks about it in his book. Man, you know what?
Oh wow, I gotta
you know
check
what?
that
You
out
know
then.
what? Hold on, I got it on my Kindle. I have the hard copy because he sent me the hard copy, but I also have it on my Kindle. Hold on, let me get it. I'll tell
Whoa.
you right now what it
Oh
is.
man, I don't know about this, man. Yeah, you gotta tell me. What has he found?
Hold on. Man, hold on. Let me go to my library on my Kindle because I
Can I
actually have it.
can I take a quick bathroom break? I'm sorry, I've been drinking tea and
Yeah,
water
no,
the
go
whole time.
ahead, bro. Go ahead, bro. Go
Okay,
ahead. Go ahead.
I'll be
Go ahead.
right back. Just give me a minute.
I'll go over some of the stuff that I found
Yeah,
interesting while you're
when you
doing
find it,
it.
definitely let me know. I'll be right back.
All right. All right. So while he's doing that, I'll show you guys. So this is the book right here. Oh shoot, can you see it? There we go. The pyramid tech, the physics, chemistry, and argo economics of the ancients. Now, let me go some of the tabs because I always like to do tabs. What I mean by tabs is there's this things called highlights. Hold on, they'll come out. Yeah, it's called highlights, things that I found interesting in the book, of course. And those are basically the tabs that I keep in my book. So let's see. Let me see. Let's see if I can find one that's really interesting because I gotta have a lot of them on here. Okay, here we go. Here's one. The step pyramid in Dozier at Saqqara processed manure and straw into methane, which was piped to the Red Pyramid too. Hold on. The Red Pyramid at Dashur processed methane to produce aqueous ammonia, which was piped to the Bent Pyramid for further refinement. The Bent Pyramid processed the aqueous ammonia into solid ammonium bicarbonate powder to be distributed as fertilizer. Hold on, let me go to some more. I have to look at. Okay, here we go. Let me see where this comes from first. This is a highlight from. Okay, this comes from. All right, here we go. When searching for a tall tower, one need to look no further than the Great Pyramid. For thousands of years, it was the tallest structure on Earth. As far as Tesla's other requirement, resonance, the pyramid's resonant abilities are the primary core principle of both Dunn's and Cadman's theories. If some of Drum's proposed chemical processes require electrical energy to enable certain reactions, it seems that the Great Pyramid is the perfect structure to support such a process. And then it says other plants, basically. To summarize, it says the chemical processing plant theories. Here is a recap of which process may have taken place in which facilities. Step pyramid, methane generation from organic matter. Red pyramid uses methane to synthesize aqueous ammonia. Drum or uses salt to produce sodium carbonate and bicarbonate. Bent pyramid, it says process ammonia into ammonium. There he goes. He's coming back.
Yeah, sorry about that. I'm
Yeah,
coming
just
back.
turn on your. Yeah. So here we go. So I was just reading. Okay, so is this book right here? Hold on, let me pull up the book for you. But is this book right here? Hold on, give it a second to load up. There we go. Is this book right here? Pyramid Tech. Hold on. Let me make myself bigger. My bad. So it's this book right here, Pyramid Tech, Physics, Chemistry.
Oh wow, I gotta read this. Yeah.
Yeah.
Okay.
So I have the hard copy too. But let me read off something that I found interesting. So I got a lot of stuff in here that's actually interesting. I just gotta find it.
So while you're doing that, I'll maybe comment on something because we were talking about.
Look at this. Check this out. See if you can read this. Hold on.
The Haber process. Yeah. So this is known. Yeah. So this Haber process is known. The production of ammonia is considered essential to society, and we know that the fertile lands around the pyramids, nitrogen is needed for fertilizers. Yep. For the nitrogen fixing process. Yeah. So does he indicate that anything about why he thinks that this is happening in the pyramids?
Yeah, here we go. I was just reading
the Haber process. If you don't know, this is totally worth looking up. It's one of the most significant inventions of all time, and this was done relatively recently. I don't remember the exact date, but the Haber process is basically modern era, and as a result, we were able to make a huge amount of fertilizer, and the fertilizer. This process allows the nitrogen fixing process to happen more easily, and that's why it's really good for agriculture. And this is what helped promote food development or food growth to support populations. This is essential today. Essential.
So let me tell you what it says. So he believes some of these pyramids were considered what he calls "quote unquote" factory or fertilizer factories. Okay, he said in 2017, Jeffrey Drum visited the interior of the Red Pyramid in Dashur, where he noticed something strange. He was certainly not the first visitor to take note of this attribute. In fact, the Red Pyramid is quite well known for it. Visitors often report a noticeable scent of ammonia when exploring the pyramid's interior. Although many people attribute the smell to the natural decomposition of bat guano, this explanation is somewhat weakened by the fact that bats are rarely seen within the pyramid. Okay.
And you wouldn't be able to generate enough. There's not enough bat poop that you're going to be able to make.
If it is, you won't be able to go in there because of health issues.
Yeah.
So this is what he goes on to say. He says, the step pyramid of Doja at Saqqara processed manure and straw into methane, which was piped to the Red Pyramid. The Red Pyramid at Dashur processed methane to produce aqueous ammonia, which was piped to the Bent Pyramid for the further refinement. And then the Bent Pyramid processed the aqueous ammonia into solid ammonium bicarbonate powder to be distributed as fertilizer. And there's more stuff in here too that talks about it. I had something else that I wanted to read to you, but I gotta look for it.
Yeah, but so that's awesome that guy found all that stuff. So did Land of Chem, and Land of Chem's channel talks about all that.
Let me show you something else
in detail.
He was talking about the hydraulic pumps. I was thinking about his book too because of this.
Large-scale water pumping techniques were employed. Yeah, I mean, we're seeing water all over the place. I actually have a picture of the Pharaoh's pump. Actually, what I'm showing on the screen is similar. It's not a Pharaoh's pump, but it's similar. I think where did I have that? This is the Pharaoh's pump, and it's actually very similar. So you can kind of see what I'm talking about. A water source coming through here. Now, what is different about the Pharaoh's pump in my idea is in the Pharaoh's pump they have this compressed air section here, and I don't even need that. I'm not using that at all. Again, I'm using a gravity fed system with just a water reservoir on the outside. It's already known, water reservoir, and it's a gravity fed system, so it's even simpler in my opinion. And also, another major difference is that they are filling the grand chamber with water. And although I know that water can go in there and that there is a setup for that, I don't think that that's what they were targeting. And I'll talk a little bit about that. But it's cool that, that's interesting that so many people are coming up with the same idea. And we were talking about language before. And one of the original names for Egypt Egypt used to be called Kemet. And this is the etymology, origin story for the word chemistry. So the word chemistry literally comes from the name of Egypt, the old name of
Yeah,
Egypt.
yeah,
And
yeah.
that's why alchemy is so interested in Egypt.
Chem.
And I'll get
Yeah.
into that too. Yeah. So again, dismissed by conventional narrative, dismissed often. And it doesn't make any sense to be dismissing this stuff, because that's as much a part of known history as anything else. And so yeah, so I don't believe that ammonia is happening in the Khafre pyramid, but I think Land of Chem has shown that it's happening in the southern pyramid of the Giza plateau. The Khafre pyramid's the
So
middle one.
I found what I wanted to share with you when you asked that question about, does he
Mm.
talk about why these things were used? So, and to summarize it, basically, he says, the step pyramid, methane generation from organic matter. He gives that from drum. The red pyramid uses methane to synthesize aqueous ammonia. Drum or uses salt to produce sodium carbonate and sodium bicarbonate. Then the bent pyramid processes ammonia into ammonium bicarbonate, and that's from drum also. The great pyramid produces and dilutes sulfuric acid or produces hydrochloric acid and hydrogen. The central pyramid combines sulfuric acid and salt to create hydrochloric acid. And then the pyramid of the sun, the one in Mexico, Teotihuacan, large sheets of mica, which is highly resistant to acids, alkalis, and other chemicals may indicate use as a protective barrier from chemical processing.
Oh wow. Yeah, wow.
Yes. So
I got to
I will
read that.
highlight.
Yeah, I'm
Yeah,
sure
it's
it's
not that long. It's not that long at all.
wow.
It's a very informative book.
I wonder if Land of Chem knows about all that. I would have to see if he's read that. Well, I'll continue along with what I know, because I don't. Land of Chem's work is so extensive. It's like at this point, he's like nailed it. He's got a lot there. I would, in terms of documenting and the visual evidence of it, and just the amount of work he's done on it, it's pretty conclusive. Let's just put it that way. It's and if nothing else, it's further indication that the geometric design of these pyramids is not conducive to anything called a tomb. So just to address some, let's address some of the conventional narratives. In the Khafre pyramid, the subterranean chamber in the conventional narrative is considered a mistake, and that they did all this originally, that they were thinking about making this a tomb, which, by the way, it's under the pyramid, not in the construction of the pyramid. And so how is that a mistake? But then on top of that, if this was a mistake, then why is it that they built this well shaft all the way up to the thing that's not a mistake? Like, what's the purpose of doing all that effort? So that's like, the conventional narratives don't make sense in so many different ways, and they make way more sense from an engineering perspective, and just some basic principles, basic physics principles. Another thing about the conventional narrative, the whole idea of the Khafre pyramid being built by Khufu, or the Giza plateau really being built by Khufu, the physical evidence for this, the entire justification on the physical evidence on the ground for this, is a red stamp in this chamber up here in the king's chamber, and this place up here, a red stamp, not an engraving, a stamp, and then a 2-inch statue of this guy named Khufu sitting in a museum somewhere. That's basically the entirety of the physical evidence that these pyramids were built by Khufu. And you got to think, for a guy who wanted to make sure everyone knew where he was buried or died, he really didn't think that much of himself if all he's got is a 2-inch statue. And this is a culture that had no problem building giant statues all over the place and all kinds of ornate stuff. So this dude that didn't have any other statues built for himself and only has this 2-inch thing and a red stamp in here really wanted to make sure everyone knew where he was built, though, or where he was buried. So so many things about this stuff are just blatantly ridiculous on their surface, and somehow they treat anyone who says anything else about these things being not a tomb, somehow they're the heathens. Now the narratives that they're talking about don't make sense, and these are not barbarians. And one of the other things is all the interpretations, all of the hieroglyphic interpretations are always slanted and heavily leaned towards barbaric ideologies, and death and sacrifice and you know, horrible things. Just that's the narratives are often barbaric, and it's also not just at this is not a problem that exists just in Egypt. This is a problem that exists especially in South America and Mexico and all that, like human sacrifices and stuff. All the narratives are about this, but this does not line up with a culture that has understood to a high degree of proficiency quite a lot of disciplines, heavy engineering disciplines, not just the. So when you add it all together, all the pyramids and all the megalithic structures all around the world, just the sheer amount of excavation that is happening, just the absurd amount of it, it doesn't make sense. Like I understand that you can have whole armies of slave labor doing this stuff, but you have to like a normal random slave is not going to be able to achieve precision like what we're getting in these pyramids. That doesn't happen by slaves. You have to be a skilled worker to do that. So you don't just magically become a highly proficient skilled artisanal worker. So where are you getting a whole army of artisanal workers and then enslaving them 24/7 for 30 years? And like none of them died doing this hard labor. So you have to replenish this stuff. And one of the things that they will often talk about, like, oh, there's enough food to they could like because this is fertile land and all that. There's enough food to support 30,000, 100,000 workers to achieve this goal, maybe. But what is often left out is where were they getting fresh water to give these workers 24/7? Let's just say that you had 100,000 workers that are working 24/7. Maybe they're working on shifts. These 100,000 workers that you're working like slaves 24/7, you have to give them at least 8 liters of water per day in order to do this kind of hard labor, fresh water. Otherwise, you're going to kill them. So, where are we getting 800,000 liters of fresh water per day? Per day for 30 years straight, every day. Where's all that coming from? So I really want to focus on water. Hopefully you've noticed that I'm a big water guy right now. Like water is a big deal on everything, and it leaves a lot of
Hey,
fingerprints.
let me ask you, have you ever heard of the Buka tribe? Let me make sure that's the right name. They create music through water. I'm not sure if that's I'll have to look it up and send it back to you. Hold on, let me look it up and make sure. Because this gentleman named Ricardo, who's an author, I shared his book plenty of times.
Oh yeah, I think I did a podcast with him.
Yeah. When he was all on that thing, yeah. He's a very intelligent individual. He wrote the book. Here it is. I'm about to bring it up right here. Where is it at? He wrote this book right here, The Resonant Earth, and he talks a lot about frequency, ley lines, and stuff like that. I'm very sure that you're familiar with that. But he told me about this tribe, and I can't remember the tribe's name, in Africa that makes sound from hitting the water. I can't remember. Yeah, I'll have to look it up or ask him if he's listening, if he can just throw it in there. But I might have said that. Yeah, I said the name wrong because when I type it in there, it doesn't show me what I want to see. So I'm definitely getting the name mixed up. But
Ricardo Calvario, right? From the School of Natural Philosophy.
Yep, I'm gonna ask him right now in the messages. I'm sorry, man. Yeah. I wish I see what he says.
I'll keep going on saltwater electrolysis for a little bit while
you're doing that. Go ahead.
So, so that's interesting that also that book is talking about finding hydrochloric acid as well. So hydrochloric acid and sodium hydroxide appearing in the same space without a membrane in between. So sodium hydroxide is a base, Hydrochloric acid is an acid, obviously. So another aspect of water filtration is its pH balancing the water when these two things come together. And one of the other cool things is that because this is a slow reaction and only two major gases initially are being produced with hydrogen gas and chlorine gas. So when the hydrochloric acid reforms into a liquid, it'll drain into the Queen's chamber where it can interact with the sodium hydroxide. This is where electrolysis is happening. And as I said, generally the point of electrolysis, the purpose, the function of electrolysis in any kind of reaction is it generally just splits whatever elements are in there apart. So if hydrochloric acid and sodium hydroxide are present again in an aqueous solution and where electrolysis is happening, hydrochloric acid and sodium hydroxide will recycle, meaning that they'll get split apart and you'll recreate sodium chloride again, or salt, and then H2O and stuff like that. So this, what's interesting is that this is like the particulate, the residue matter is recirculating. And so why are we doing all this? So all of this is, again, step-by-step processes of how to filter water, how to clean it up, right? Remember, originally we started with seawater that just has all kinds of stuff in it. And just through this simple, just running a current through salt water and heating it at the bottom to kind of, and dumping like the high debris, just simple things with a gravity-fed system already do quite a lot to just clean water. And we know that the pyramids are filled with quartz sand for the piezoelectric effect. And when you hydrolyze limestone, which is a construction of the pyramids, wherever the water comes in contact with limestone, hydrolyzed limestone specifically is not inert. It'll create a little bit of a conductive property to it. And this will create a vector of travel. And so the piezoelectric effect from all the quartz sand will have a direction of travel once water enters into this system. And then you'll be able to also generate a little bit of piezoelectric effect current affecting the water just from this alone, especially with the size of the pyramid that we're talking about. And we know the whole pyramid is filled with quartz sand. And in my opinion, that void that they found over the Grand Chamber is probably also going to be filled with quartz sand. Kind of think of it like a battery almost, just basically something that's storing a lot of charge. In your head, you can think of the entire pyramid as being filled with static electricity, and it just needs to have a direction of travel in order to utilize it. So hydrolyzing limestone, I'm not going to say it's a conductor as strong as copper, not that much, but its conductive properties significantly improve. And that's how where water comes in contact with the limestone is specifically where you would want the electricity to go. So you only want the parts to be conductive that are in contact with water. So it all just works very simply, very easily, very cleanly, without much like external machinery required in order to achieve some very significant results. Now, one other thing I want to say is that saltwater electrolysis is creating a lot of pressure in this headspace. So hydrogen gas is highly explosive, and it'll also increase the temperature the more you do this. And I'm saying that in the subterranean temperature, subterranean chamber, they're heating the water, and the hot water is the one that's coming up. So what else is happening here is that we're creating a high pressure system. And now we got to be careful because hydrogen gas is highly explosive. And another reaction that gets favored when you put this system under high pressure and high temperature is oxygen also gets favored. I'm not saying the yields are very high. I'm saying that oxygen becomes a more favored part of the reaction when you put this system under high pressure and high temperature. So the oxygen molecules will also on occasion break off, and you'll start filling this chamber with 3 different gases: hydrogen gas, chlorine gas, and oxygen gas. And the chlorine gas should recombine with the hydrogen to create hydrochloric acid. It gets recirculated in the system. So now you have hydrogen gas and oxygen gas. And as long as hydrogen gas and oxygen gas are both in high energy states, they don't necessarily recombine into water. So once you have a high pressure system, the gaseous elements, H2 and O2, these 2 elements can vent out here and go into the grand gallery. And so this is what I think the Grand Gallery is primarily for. The Grand Gallery, in my opinion, is designed in such a way so that it can trap large amounts of hydrogen gas and maybe oxygen, some oxygen gas as well. And the reason for this, something discussed by Christopher Dunn, is these Helmholtz resonators.
Yeah,
And
I
this,
remember that.
and this goes back to that structure I was talking about in the Arizona Biltmore Hotel. Remember that with the sound amplification? So Helmholtz resonators do this. So in my opinion, so one thing that we do know is that the grand chamber is acoustically tuned. And I know that there's a couple different numbers out there for what is the frequency that the grand chamber is tuned at. One thing to note is that the grand chamber is not tuned to the same frequency everywhere. The top portion of the grand chamber is tuned to a higher frequency than the lower portion, and there's a gradient here. And so what I'm trying to argue is that the reason why there's a gradient starting from lower frequency going to higher frequency, and the number I'm going to use is 440 hertz. This is, I know that there's another person that says they measured at 432 hertz at the top. I think Christopher Dunn, when he did his personal experiment, he found that these were tuned at 440 hertz. So that's the number I'm going with. The reason why I think it's starting at a low frequency and stepping up slowly to a higher frequency, eventually to 440 hertz, is because I think you're trying to be gentle about the cymatics process. So cymatics is well understood, but just to give a little brief analogy to make it easy to understand, the reason why snowflakes get their crystalline structure is discussed in cymatics. Sound vibration and other things like infrared can influence the hydrogen bonds on H2O, and you can change the orientation or the angle of the hydrogen bonds in H2O, and then this will create different kinds of crystalline structures. So that's why snowflakes have so many, because you can literally move these hydrogen bonds all around the O2 or the oxygen molecule any way you want and create all kinds of angles. And so you can create almost any kind of crystalline structure with it. So this is, I know a lot of people are looking at cymatics as a way of treating water as well, and maybe that's what's happening there too. But I don't think, in terms of the physics, what is the physics advantage of cymatics? Like, what are the engineering utility purposes of cymatics? In my opinion, it's more about angling these bonds. It's less about filtering pollution, and it's more about angling these bonds. So what I mean by that, another way to understand what this terminology of tuning a hydrogen or H2O molecule to a certain frequency, another way of understanding this terminology is it's controlling the spin. You can control the spin, basically control the spin by applying sound frequency, or another way of doing it with water is infrared as well. And maybe I'll talk about it, but one of the things I want to maybe indicate is that these pyramids are multifunctional, multidisciplined, and they're making an engineering decision to switch to rose granite in the King's Chamber, and I believe it also existed in the Queen's Chamber. That's an extreme labor cost intense decision to make, which means that serves a purpose. Something that Christopher Dunn has talked about, and there was a TED talk by a scientist that looked at specifically rose red granite, the same kind that they're using in the pyramids. They've looked at rose granite in mass, just out in the wild, wherever it is, and they found that before earthquakes, the mechanical stress from tectonic movement, if it is in an area or region that has granite, they will see on infrared, they will see on thermal imaging infrared coming off of these granite deposits all over. And they've successfully done this many times. They've successfully been able to predict earthquakes a few days in advance just by thermal imaging of granite deposits, because granite, when you apply mechanical stress to it, emits infrared light. And so they can do this where they can see this infrared light a few days before the earthquake actually hits. And this has been demonstrated many times. So that's really cool. And so I think, and so the reason why that might be relevant is because there's a lot of mainstream published research that is well understood that infrared light therapy generates health benefits. And we know that the human body is overwhelmingly composed of water. And so it would make sense if infrared light therapy has health benefits and you're talking about treating water, infrared light might be relevant to this filtering water process. And they've shown that infrared light can also remove pollution just like cymatics. And in fact, that's the whole point, is that infrared light is one method that operates similar to cymatics, and you can adjust the bonds of water this way. So all the same principles apply. All this stuff applies. So what I want to get to, though, is that in the grand chamber, I'm saying it's not about water, though. I'm saying it's about hydrogen gas, and it's in context with oxygen. And so the reason why you want to have the Helmholtz process going on here for cymatics is, again, I think the major physics advantage of cymatics is controlling the spin. And what I'm trying to say is that once you have hydrogen at a high energy state, hydrogen gas at a high energy state, in order to keep it there, you want to increase the frequency of this hydrogen gas to keep it at a high energy state. If the hydrogen gas falls to a lower energy state, it isn't generally stable. That's why hydrogen bombs and stuff like that exist. Hydrogen will, if it falls to a lower energy state, it'll want to interact with the oxygen, and it'll generally reform into water. And if that happens, which I think it does happen frequently in this process, it'll happen, it'll drip to the bottom, and it'll just go down to the Queen's chamber again and recycle into the process. But the point is, you want to try to achieve that high energy state. And so what you're targeting, in my opinion, in the grand chamber, and we know that there's like this step process that's going on here, and all the shaping of the grand chamber is showing step patterns like this, steeple step patterns. And I was demonstrating that this is demonstrated in real life at the Aztec Room in the Arizona Biltmore Hotel for sound amplification, specifically up, not down on sound. So why you want to do this is because you want to target a high frequency for hydrogen and maintain it at a high frequency. So the hydrogen gas is lighter than oxygen. And if it retains its high energy state, it'll continue up the grand chamber as a gas, and it'll continue in this cymatics process. And the hydrogen that's at the top will be the highest energy state hydrogen gas. So not all hydrogen gas is at the same energy state. There are multiple energy bands for hydrogen. And what I'm trying to say is that the point is to achieve the highest possible state for hydrogen. And that's what's being trapped at the top of the steeple, top of this pyramid looking steeple structure. In here at the top, you're going to have the highest energy state hydrogen gas. So I think I accidentally exited. Well, that sucks. 1 second. I need to pull up the antechamber again for the pyramid. So there's something that, oh man.
It's all
Okay.
good, bro. You know how it is.
Yeah, sorry. I need to get better with this. So there's a couple things I want to address here. First, I want to address the conventional narrative. So this is what the antechamber, the top end of the grand chamber, looks like. So we know that there are these three large rocks right here, and there's this like rock that was supposed to be suspended up here, and we know that there is a system that looks like a pulley system in the antechamber, and that there's this void right here. So more ridiculous stuff about the conventional narrative. Conventional narrative is that these blocks were put here to prevent access into the king's chamber so that people couldn't steal whatever was in the tomb. Well, the problem is that there's this big giant void right here, and these rocks are easy to climb over. It's like you can human for scale right here. Now, these are really heavy rocks, but they're not that hard to climb over. So the conventional narrative already doesn't make sense. And so what I'm suggesting is that this was a pulley system where there were ropes attached to this, and these three blocks, it's not a great picture. There were ropes attached to these three blocks, and there was a pulley system where this large block was suspended in the air. And what I'm saying is that if oxygen and hydrogen at lower energy bands, the ones that didn't hit all the way through the cymatics process. So it will be a low yield for the one hydrogen gas that's sitting at the top. That's going to be a relatively low yield, but that's fine. Most of the hydrogen gas and oxygen will vent into this lower exit that's leading towards the King's chamber. And it'll vent into this void that's in this section right here. And what'll happen is if this section, this will create another high pressure zone. If this section becomes high pressure, too high pressure, it'll push this block down and it'll allow this block to rise. And then you'll be able to vent oxygen and low energy band hydrogen out into the King's chamber. And then what can happen from the King's chamber is you can vent oxygen and hydrogen that didn't work in the process, or it can recombine. So only the high energy oxygen and hydrogen will vent out of the shafts in the King's chamber, and that will stimulate rain cloud production. But if the oxygen and hydrogen fall to a lower energy state, that'll just reform as water, and it'll drip down back into the Queen's chamber, restart the process all over again. So that's really cool. You just get a free way of venting steam, effectively steam. And you get a free way of generating hydrogen and oxygen. Again, all we're doing is saltwater electrolysis under high pressure, and there's a shit ton of weight in this pyramid for high pressure. We also know that there's massive explosions that have happened in the Khafre pyramid all over the place. There's soot marks everywhere. There's multiple signs of explosions that are happening in the Khafre pyramid, both in the King's chamber and in the Queen's chamber. And one of the things I wanted to show, where do I have it? Uh-oh, did I lose that one too? I wanted to show the King's chamber granite box. So you've seen the granite boxes that are at the Serapeum, really heavily engineered, polished, or like precise, very clean. But the one in the King's chamber is like wrecked. It's destroyed. It's even got a corner missing. It's like rough cut and all this stuff. But this thing is heavy as all hell. This is not going to be the only granite box in all of Egypt that is not like all the others. So what I'm trying to say is that this granite box was originally the same level of precision and cut style as all the other boxes in Egypt too, all the other granite boxes in Egypt too. What happened here is that there must have been an extremely high temperature situation that occurred in the King's chamber. And Christopher Dunn's team has looked at the mechanical stress that was applied to the King's chamber on the wall blocks, and it definitely shows signs of an outward explosive mechanical pressure that happened. So one of the properties of granite is that when you put granite under so granite absorbs heat really well, really easily. And when you put granite under high temperature, one of the things that happens is it deforms. But whenever you cool it down, it has this unique property of returning to its original shape. So in order to make granite specifically deform under high temperature, you would have to hit an extremely high energy level to achieve that. Otherwise, it should have, after it cooled down, it should have returned to its original state. So the amount of uniform, clean disruption in the original shaping of this granite box, which I'm going to argue is supposed to be at the same level of quality as the Serapeum and every other granite box we find in Egypt, that is a indicator of some high energy physics happening in this area. And so that's really what I want to get into, is the second half of the story for the pyramids in the Grand Chamber is all about high energy physics. So there's a lesser known passageway at the top. This is known though, but it's lesser known. At the top of the Grand Chamber, there's a hole right here at the very top. And what I'm trying to argue is that hydrogen gas, the high energy state, hydrogen gas, is being funneled at the very top into this little hole passageway to the top portion of the King's chamber, this section. Now, the reason for doing this. So think about what you have. If you have hydrogen gas at an extremely high energy state, then this is the closest thing you can get to a proton. If you extract the electron, one electron off of this hydrogen, you have effectively a proton, just a proton. So what I'm trying to say and what I think is happening here is that they are controlling this. They're going through a step-by-step process because they're trying to be gentle about the cymatics process. Because if I'm right, they're filling this chamber, this giant chamber, with hydrogen gas, and it's in contact with oxygen gas, and both of these things are high energy and both of these things are highly explosive. If this thing goes out of control, then this is like a hydrogen bomb effectively. So that makes sense why these things, these structures, have to be put inside massive heavyweight pyramids. These things are embedded deep inside these heavy structures. This is a safety mechanism. And we even see a few regulating mechanisms. We know that there's a granite set of plug blocks right here, and it's at the end of the shaft. If you move this granite block right here, this would act as a pressure relief valve. And so we've seen major explosions all throughout this setup. And so if you had a massive amount of pressure that went out of control, what you would do is you would have this granite block move all the way down this passage, and it would hit this descending passage, and it would block the water flow. And that would stop the reaction from continuing further. And again, all happens with blocks. And we know, and I just described the regulating mechanism over here. If there's a high pressure system on the other side of the grand chamber, you also have a relief system set up. And now, in my opinion, this was supposed to be more functional. It was supposed to be a regular mechanism that would regularly allow pressure relief, and it would regularly vent oxygen and hydrogen that was at a lower energy level to maintain stability inside here. This one, I think, is the emergency shutoff. If it got too big and this one isn't able to control it and the pressure is out of control, this one's in my opinion, this one's the emergency shutoff. So why would you want to do all this? If you have hydrogen gas at a high energy level that's all tuned to the same frequency, so another way of saying that is spinning in the same direction, spinning the same way, and you're collecting that into the chamber above the king's chamber. What this could possibly be is one method of maybe performing transmutation to generate high atomic weight particles. And the reason why I think this is because this is all under a very high pressure system. And this zone is deep inside the pyramid. It's right in the middle of the pyramid, and it's got this triangle shaped roofing on top, which means all the weight on top of it is being concentrated on that structure right there. And if you have that kind of shaping, triangle shape, which is the strongest shape, and you have a method of collecting just the hydrogen gas that is at the highest energy state, one thing that is understood is that the stability of elements is mostly controlled by the geometric crystalline structure of those elements. In other words, the shape of the element is what determines its stability for the most part. So you can effectively create any kind of element as long as you put it into a state with protons, as long as you put it into a stable crystalline shape. So you got to think about our current tech. Currently, in order to generate high atomic weight elements, what we do is we use a Large Hadron Collider, and we take base elements, we spin them as particles of these things as fast as we can in opposite directions, and then we smash them together as fast as possible. And maybe for a fraction of a second, you can get a high atomic weight element of some kind. But there's so much kinetic energy in this process that when they interact, there's no possible way anything will be stable that way. So this is not even close to how you would generate any kind of high atomic stable structure. But in this system, with these kinds of controls, doing it slowly, controlled, in a step-by-step sequential process, you have created a zone and a space where you can generate a lot of control over the shape of this hydrogen gas. And another thing about protons, they would be positively charged. And I'm saying that the pyramids can be thought of as diffuse static electricity, negatively charged. So another thing is, not only are you getting the weight of the pyramid to come down and create a high pressure zone here and control, and also create just layers of safety in case this reaction goes out of control, which apparently it did. You would be able to control the shape, and you would have positively charged protons, and you would have basically negative charge all around it. So not only are you getting weight, gravity of being pushed down onto this to control this high pressure system, but you've also got an electromagnetic attraction between the positive and negative, really adding more pressure, just combining multiple principles all at once. And so it would make sense that you would want to fuse electrons into a stable structure as soon as you've got the structure of the protons figured out. And in my opinion, they're probably, like I'm saying, high atomic weight. I'm sure that's possible. But in my opinion, based off of the stories, what I actually think in reality that they're actually trying to manufacture here is not actually really high atomic weight elements, although the principles that seem to be described here seem to make it that an option. But in my opinion, based off of the stories, if you look at alchemy in Egypt and you see this salamander symbol, which is very symbolic in alchemy and very common and very important. In my opinion, what another name for this salamander description is milk water. And another name for this salamander description is mana or mana. So what I think that this
Wait,
concept,
hold on. What you say? So say that part again. What was that? That you said the other one was mana. What was it?
mana. There's another name for what this salamander description is describing. Yeah. Mana and milk water, both are describing the same thing, symbolic with the salamander. And you can think about the name. They use the naming salt mana, something like that. So you can kind of see where they were getting it. So in my opinion, what this actually is, what they're referencing here, and what, in my opinion, this ankh, there's a container that this ankh is often associated with. In my opinion, what's inside this ankh container is deuterium, H3O, heavy water. And that's what I think they're actually going for here, in my opinion. And if you can take just another giant leap of faith, if you want to believe, like, if they're understanding high energy physics at this level, then radiation is not that hard of a concept for them to understand, if that's true. Anything I'm saying is true. So another thing they could be going for is tritium, which is just another layer above deuterium. So all this is water. It's water being elevated to higher and higher energy states and becoming more and more complicated. And now you shouldn't drink deuterium, FYI, not in large quantity. But there is an argument that could be made that drinking small quantities of deuterium might be beneficial to your health. And so again, I just want to circle back. I want to demonstrate that the initial and primary and functional purpose of the Khafre pyramid specifically is for water filtration. And that's the argument I want to primarily build on. All this high energy physics stuff looks like features that they added on top of just that primary function. And we are seeing numerous principles related to water filtration all in the same place. The rose red granite is infrared, that's water filtration. The cymatics, water filtration and control. Heat, water filtration and control. Hydrochloric acid and sodium hydroxide, water filtration, and chlorine gas, water filtration and control. So all this stuff is related to water filtration, controlling water. So why wouldn't the end steps also be about advanced versions of water? So primitive understanding and building up sequentially through the step-by-step process that they've literally just built out and mapped out right here. This thing, I think, is stepping up water and making it more and more, let's say, advanced. And so I think that also there is a lot of health benefits to structuring water, the crystalline structure of water, in a specific way. And I think that's kind of eventually where the research around infrared light therapy on the human body is eventually going to go, is that it's the reason why infrared light therapy might be working, maybe at least in part, especially to reduce inflammation and things like that, is because maybe it's changing the crystalline structure of water in a certain way, and that there are certain ways and angles of the bonds in water that are more beneficial to your health than just drinking normal water. And so I think that this water filtration process is the first and primary and most important function of the Khafre pyramid. And I believe this water is being used for drinking water and also for reactions elsewhere. But also, I think they've stacked on additional features beyond that. And so that kind of is a rough overview of what I think is going on at the Khafre pyramid. And I hope maybe some people can kind of help me play with this idea and see if this makes any sense to anyone.
Yeah, I think I'm sure it will, because there's a lot of people who are interested in it. I mean, you have people in the comments already thanking you for what you're sharing right here. I mean, look right here, you have people thanking you. So obviously, what you're sharing is very interesting. Like I said, when we met at Cosmic Summit, you talked the whole way about this theory up there, and then you even talked about it on the way back.
Mm-hmm.
And you even actually talked about it, some of it up there while we was waiting for the buses to come up there, right?
I can keep going.
So,
I can keep going.
yeah. So
I haven't even
obviously
described everything. I just did the core process, but there's a
and
lot
hopefully
more
we
that
can
I
do
could say.
that. And I know you say you have some things to do today, and
Yeah.
I'm on your time and stuff like that. So,
Yeah.
like I said, we can set this up again and do this again another weekend. I mean, you already said you want to get more into it. I would love to. I'm
Yeah.
listening to it. I'm taking notes. I mean, people are obviously listening and watching. There's 141 people watching it right now.
Oh wow.
By the time this ends,
wow.
or by the time next week, there's going to be about 300 or 400 or 500 people who's going to watch it. So your name is getting out there. Plus, you've done 4 or 5 already podcasts, and you've done 2 with Mike and Dave on Mike and Dave's Multiverse. You've done one with me and Nick's team and Cult Rejects that he gracefully let me be part of.
Yeah.
It's you got a lot of stuff, and like I said, stick to the topics. Like I'm like you when it comes to the Sumerians. I can talk about the Sumerians a lot because I know so much about them, and just like you, I'm very knowledgeable on other subjects, and I just need to educate myself more on them. But my expertise is the Sumerians, the Anunnaki. Like I know that like the back of my hand, and I have facts, and I've been studying them for years. And I what I go against is what some people's narratives are, right? But I have facts to back up my narratives, just like you have the chemical process of how these things are supposed to happen. And I just showed you the book that I got from Ken Goodsword. He's actually an author and a distributor. He has his own publishing company, and I actually follow under his publishing company. I wrote my first book, Journey Through the Origins, through him, under him. Wow. So it's people like, what's up? Go ahead.
Yeah, like my home base is more on the engineering side, but what I think you bring to the table is you have an extensive knowledge on the mythology side, and you've studied a lot of civilizations. So what I was trying to say before was that it's not just like this is only in Egypt. These megalithic structures are everywhere in the world. Every civilization was able to achieve a high level of advanced technology all at the same, or maybe not at the same time, but they were all able to achieve it. And we are seeing this demonstrated over and over and over again, not just one time, everywhere in the world. This is too many times has it happened for it to be a coincidence. It's not a coincidence. And so some of the things I kind of like as a teaser for maybe next time, I want to kind of recommend this video if you want to know about the Khafre project and how their technique works for the SAR scans, where they're showing columns underneath the pyramids. And a little bit of what I didn't talk about that I also think is relevant to the Khafre pyramid that is different than what I think even the non-mainstream conversations that are being had about the Khafre pyramid. Another thing where I deviate from even the people that are looking at these as like energy or chemical systems in my opinion, the Khafre pyramid and other megalithic structures around the world, they're also putting a lot of effort into dampening energetic noise from all sources. So we know that the Egypt pyramids were originally encased in white limestone. And then they have this more porous limestone that the majority of the construction of the pyramids is. And in my opinion, the reason for this is because they're using the white limestone on the outside to reflect all visible light and UV light. And the reason why they switched to the more porous limestone on the inside is not just about the conductive properties when hydrolyzed that I talked about, but also because more porous rock is easy. It traps sound. So another way of saying it is that they're using this rock to trap sound waves, because I think what they're trying to do is they're trying to dampen energetic noise from all sources from the outside. And why I want to bring that up in context with the SAR scans is because we saw that the SAR scans, the pillars and the recreation that they made showed like these spiral coils that are going around whatever these columns are underneath the pyramids. And in my opinion, the reason that they're doing this is because these are kind of like shock absorbers. These are literally look like springs to me. And I know that there's a big conversation about the pyramids maybe being acoustically tuned to the frequency of the earth, and that might be relevant. But in my opinion, what we're seeing here is that these are dampening structures. And another way of kind of understanding this principle and visually seeing it. So, and I want to offer a little bit of credibility to the SAR scans because I want to apply a little bit of my AI and signal processing knowledge. So I'm not going to be able to, I'm not going to be a source that either validates or invalidates what they're doing. I just want to offer one point that adds credibility to what they're saying. And that's it. So what they're trying to show is that they're pulling this signal in the SAR scans from underneath the pyramids. And one of the criticisms I've heard is that these columns can't possibly exist because they're going through a water table. Well, if you understand their technique and what it's doing, the technique that they're using is trying to measure the vibrational noise of the structures itself, and then compare that vibrational noise to the vibrational noise of the environment around it. And what this technique is supposed to do is it's supposed to identify large differentials in the vibrational noise from the structure itself and the environment around it. So what you're seeing here is you're seeing strong red signal right up here. But what happens is that as soon as these columns, and you can see the faint outlines of them barely, and when these columns hit the water table, which is this is roughly about where you would expect the water table to be, the noise dampens abruptly. And if you believe what this team is saying about what their technique does, this is actually the kind of result you would expect, because water is a liquid. So if these columns are going through the water table, then what's happening is that the vibrational noise of the columns is being absorbed by the water around it. And this technique is supposed to measure the differential between the structure and the environment around it. So if the water is vibrating at the same frequency as the structure around it, which is supposed to happen, that's normal, then you're not going to be able to pick up that differential as easily. And so I've been hearing that criticism that the columns can't exist because it's going through the water table. No, this result is exactly what you would expect. You would expect dampening of the noise immediately, abruptly, as soon as you hit the water table. And what's interesting is maybe a way of kind of confirming this. On this specific structure here, it appears that the water table kind of dipped a little bit. And maybe another way of kind of side confirming what they're saying is if there's a way to specifically look in this region and see if the water table that's underneath the Giza pyramids, does it actually dip? And if so, that might add some further credibility. Now, I'm not trying to say that that's enough to say that what they did is right or wrong or all this, but I'm just trying to say that they're being consistent. Their technique and their results are being consistent, at least so far. Now, I don't know how they were able to get a signal from a kilometer down into the earth, but that doesn't mean they didn't. And that's pretty cool. You know, this technique is hard. In my opinion, just from what I've seen of their presentations and watching their discussions multiple times since they've initially released this in March. In my opinion, it seems like they're making a good faith effort, at least. And I want to give, I want to say this because I want to make sure that what's not lost in all of this is the level of difficulty of what they are doing. And if they achieve this, and by the way, they've demonstrated this technique on a variety of other structures that are known. So this technique does work on other structures that have known structures. But if they actually pulled this off and it's proven that in the end, these guys deserve a ton of respect. Like, this is hard. Like, doing it from satellites in space at the distance they're doing it, using the technique that they're using, this is hard. Not impossible. Not impossible. There is a mathematical logic that does exist. And there is something in signal processing regarding fast Fourier transforms that does allow this technique to work, and that is understood. Now, did they actually, like I was saying before, theory is one layer of difficulty. Pulling this off in real life, that's a whole different, like 10 times harder at least. So did they actually pull that off in reality? That's to be determined. But if they did, this is like one of the coolest things ever. And these guys should deserve a ton of respect if they actually did pull this off. So, you know, I wanted to give them that respect because if it's real, I want them to do this with the Taj Mahal so bad. If they pull this off, like, I hope they do this with the Taj Mahal someday, because this is another structure that doesn't make sense. And it resembles a lot, it indicates a lot of the same mechanics that I was describing in the Khafre pyramid. The Taj Mahal has many of the same mechanics. White exterior, porous red sandstone interior construction, acoustic tuning in the central area, layers of construction underneath. These arches and stuff are related to acoustic tuning. Water, artificially created water body underneath the Taj Mahal. Ornate and heavy boxes in the center area of the Taj Mahal. And so much more. And also, just like every other archaeological site, so much of this has never been explored. And not only that, but they've sealed up the entrances now. So numerous entrances that would have allowed us to explore these bottom areas, they've been sealed up and you can't access them. So not only restricted, completely sealed. So that's a real shame. And something that I think that I hope people start to look at is India, because in India, there are so many megalithic structures. They're all called temples. And this one's called a tomb, though. And these there's not just like a few, there's hundreds, maybe thousands of megalithic structures of all different types in India. And the major difference, and the reason why I'm highlighting the ones in India compared to everywhere else in the world, is that the ones in India are ornately carved, regularly, frequently, commonly, and they are well preserved relative to all these other megalithic structures. One of the big advantages that India has that the rest of the world didn't really have is that in the north, India is bordered by the Himalayas, and then it's a peninsula, so it's surrounded by ocean on the south. So what that means is that for most of history, through and India is an ancient civilization. It's one of the only ancient civilizations that's been long running from way back when and still continues to now. It's an ancient civilization that, relative to other countries in the world, it's relatively untouched. I'm not saying there wasn't any war. In fact, there's a story about the British when they came to the Taj Mahal. They lined the entire Taj Mahal up with dynamite, and it's totally worth hearing that story. And they came within moments away of destroying the entire Taj Mahal. They had the whole thing ready to go. They were ready to push the plunger and go. One of the things that tipped me off that maybe the top of the Khafre pyramid is gold is something that's not well known about the Taj Mahal, is that the top structure, the top little spire right here of the Taj Mahal was originally gold, and the one that's there now is not the original. When the British came in, before cameras existed, they took this gold spire that was at the top, whatever it was, and they melted it down. And so we have no idea what the original shaping or structure of the gold spire is at the top of the Taj Mahal, and there's no pictures. So fortunately, they didn't destroy the whole Taj Mahal. And one of the things I wanted to convey is that India has its own form of hieroglyphs. It's all these ornately designed carvings, and every square inch of Indian megalithic construction is ornately carved, and beautifully so. And so I'm going to go to India in a couple weeks, and I'm going to try and document a lot of this. But I'm going to suspect that the same way that if you look at hieroglyphs as a pictographic language and just ignore whatever nonsense translations they're giving you and just apply an electrical engineering lens on top of it, or just a logical lens on top of it, I think that the same thing is probably going to work in India, and I'm going to go see if that's true. So I hope we can generate some support around India, because I think India, I hope that India would be proud of all their megalithic construction and how much India would have to offer this conversation if they wanted to get really heavily involved. And if India would understand that everywhere else in the world is being resistant to advanced technology, and they could lead in a way that no other country could, I mean, I think they could have a profound impact on this subject for the whole world. And I think that India will also be able to establish its a whole new world for themselves with this kind of stuff. And water is a huge part of India too. The Ganges River is a sacred river. So come on, water is a big deal in everything.
Yeah, right on. That's why I always say, every civilization that you find that started around 3000, 5000 BC, 3000 BC, they all started by a body of water, but that's not a coincidence. That's because we need water to survive. Water is
Right.
needed for our survival. So we need to be as close to it as possible,
Right.
at that time frame.
Yeah.
So, and the stuff that you shared was very interesting. Like I said, we didn't even get into Thailand. So like I said, I know you got to go. So how
Yeah.
about this? We talk about Thailand next time.
Yeah, I
Set up
just
for
want
next
to
week or so.
put this up there.
Yeah, go
There's
ahead.
some weird stuff that's going on, and I don't want to get too deep into conspiracy anymore, just because so much has happened. But all I want to say is some stuff that is conventionally understood. So Graham Hancock talks a lot about how the shafts of the pyramid, the Khafre pyramid, are pointed at various stars. One of the shafts is pointed at the star Sirius A. And this is an infrared image that was taken by a French lab, I think in 2017, in infrared of the star Sirius A. And this arrow is pointing to the sister star Sirius B. And there's some stuff about this that I want to talk about, but really the crux of what is important here is that throughout history and throughout, especially in modern era, like within the last 150 years, a lot of people that have researched the Sirius star system have indicated that there must be a third body somewhere in this star system, and it must be relatively small. And the reason why they think of this is because the orbits are irregular. They're not. Their orbits would make more sense if there was a small third body in this area. So these are the two major bodies, and this is a blackout aperture. According to the paper, this is called a blackout aperture that they're putting on the star so that they can filter out a lot of the noise and it doesn't blind out the telescope. But Sirius A is the brightest star in the sky, and it's common in mythology, not in just one place, all over the place, because it's the brightest star in the sky. And in Egypt, in the hieroglyphs, there's this dog-headed character, and this dog-headed character is called Osiris or Sirius. They're both the same name. And in the stories, they say that this dog-headed character comes from this star system. And there's also multiple accounts of this star redshifting at some point, where it wasn't originally, and then at some point it changed colors. So all I want to say about that is that maybe there's something going on here too. And it would be cool. I've seen some stuff and I'm not able to prove it, so I don't want to say too much. But I think that it makes sense that there should be a third body in this system. And it's the brightest star in the sky. It's not that hard to find. So maybe it could be some low hanging fruit to just look at this star system and see if we can locate another third body. And I think that would be really cool, because if we can find a third body in the system, maybe we're looking at a relatively close star system. I'm not saying it's super close, but relatively close star system compared to all the other stars. And we might be able to find something cool right in our quote unquote backyard, celestially speaking. And I think that maybe if we put some more infrared cameras pointed, or telescopes pointed at Sirius A, hopefully we might be able to find something. So that's it for me. I've rambled enough for today.
Yeah, I agree with you. I think they should point more, but see, the thing is I think they already are. They're just not telling us as much, because most of the stuff is in mathematical format. Like you said, you're good with math, and most of the stuff that they find out there is based off of math. It's not based off of, they get to see a whole new planet in the circular or whatever type of shape that someone might believe it's in. They only see it in,
If I had to guess, if someone with a powerful enough to get an image like this, if someone had a powerful enough telescope in infrared and pointed it at Sirius A, I bet you would see something visually. I think so. But just my guess.
Right on. Well, okay, so we're at 2 hours and 50 minutes. There's people still jumping in. It jumped up to 151 viewers just awesome. In the last 2 hours. There's been a couple of people that's been in here with us from the beginning, just like Ancient Vacuum and Kuru Craig. I always mess that up. But these individuals were with us in here messaging, and they were enjoying what you were saying, obviously. So I appreciate everybody that came to listen. Hey, before we end this,
let me say one thing. Sorry, I mentioned Osiris, but I forgot to bring in something about why that's relevant. So the reason why I'm bringing all that up and bringing Osiris into the picture and saying that the stories say he comes from the star system, one of the other things they say about Osiris or Sirius is that dogs can hear really well. And what the stories say from this star system is that they say from this Sirius star system emanates beautiful music. This is in the stories in Egypt. And there's also depictions and murals on the wall of on the walls in the hieroglyphs showing Sirius like turning some sort of contraption and a liquid being dripped into a jar. So what I'm trying to say is there's a lot of contextual clues, and all we need to do is prove it. That's it.
I agree. Hey, Ancient Vacuum put out there the Contact movie by Jodie Foster. That's actually a good movie. Also, another good movie is the one with Charlie Sheen. I can't remember what it's called. But hey, just share your handles and everything that everybody can find you on, and then we'll close it out.
Yeah, you can find me on X right now at message for Ashish. That's the number 4 Ashish. I'm social media illiterate and I'm trying to figure it all out. So I'm sorry that I don't have more than that, but I hope to maybe start a YouTube channel and do more. But I've been doing all this by myself for years, and I'm self-funded entirely, and I don't have a job. I do this out of savings, and I'm traveling all over the place just out of my own pocket. So if you want to help me out with a little bit of travel expenses, maybe you can find a buy me a coffee link on there, or just look at all my stuff and see if you're interested. And if anyone wants to help out in figuring this stuff, like we need tons of people all over the world. We need everyone. We just everyone. And I honestly cannot think of a more interesting problem to solve in the world right now than this stuff. This is the most interesting problem in the world to solve by far. And I think it's profound for everyone. And I think that this belongs to all of humanity. And that's the key here, is that there is something here that belongs to all of humanity. And that's why it makes it the most interesting problem to solve.
Right on. I appreciate that. So everybody that listened, thank you for coming out and listening to us. We're going to have more live shows on here. Ashish is definitely going to join me more often on this stuff too. And I'm going to just start presenting more live shows just like this. I'm also with the Occult Rejects, which I'll be able to live stream with them. And I'm also with Universe Unveiled. So yeah, we're going to start doing some things. Ashish, I really appreciate you sharing your knowledge, bro.
Thank you, everyone. Thank you for listening to me.
All right. All right, everybody. All right.